Good morning, everyone. I'm Julius Janikowski. I'm the chairman of the FCC, and happy first day of March Madness. Yes. Anyone caught filling out a bracket during this panel will have their smartphone confiscated. I just want everyone to know that. But seriously, welcome to the FCC's first workshop of our Technology Transitions Policy Task Force. I'm so happy that Commissioner Rosenworcel and Commissioner Pai are here. You'll hear from them afterwards. Thank you all for joining us. I want to thank our panelists. I see many familiar faces who've come in from out of town yet again. The other Washington, not a fast trip. I want to thank Sean Lev and the other members of the FCC staff who worked hard to organize this panel and a lot of other work that's being done on this important topic. Rebecca Goodhart, who's serving as the task force's deputy director. When I arrived at the commission in 2009, it was clear that this was a time of rapid technological change, and that change has only accelerated. At the start of 2009, 16% of mobile subscribers had smartphones. Today, that number is 55% and climbing. Back then, the commercial tablet market didn't exist at all. And today, roughly one-third of Americans have a tablet or e-reader. Some analysts project that tablet sales will surpass PC sales as soon as this year. The percentage of households cutting the cord has roughly doubled, and more than a third of U.S. households are now wireless only for phone service. At the FCC, we've been working to make sure our communications policies keep pace with this change. We, of course, developed the country's first national broadband plan, providing a strategic roadmap for the transition to all IP networks. As recommended in the plan, we've adopted landmark reforms of the Universal Service Fund and overhauled inter-carrier compensation. We've sped the transition to next-generation 911. We've ensured that VoIP service remains accessible to individuals with disabilities. And just last week, I circulated an NPRM proposing that VoIP providers receive direct access to numbers, phone numbers. The proceeding on direct access to numbers for VoIP was a recommendation of our Technical Advisory Council, or our TAC, led by Tom Wheeler. The TAC had another early recommendation relevant to today's session, and it said the Commission should, and I quote, establish a task force to conduct a thorough policy and regulatory review as it relates to the PSTN, which results in policies for the new communications environment. Following TAC's council in December 2012, I announced the formation of an agency-wide technology transitions task force to provide concrete recommendations to modernize the Commission's policies, recommendations that would build on the Commission's previous work. We said this process would be open and data-driven, and consistent with that promise, we're conducting a series of public workshops, of which this is the first. Today's main objective is establishing a factual baseline for understanding three key transitions. One, the evolution of network protocols from TDM to IP. Two, the replacement of copper networks with fiber. And three, the shift from only wireline service to greater use of wireless service. We've scheduled 3 panels today comprised of a broad sector of experts from inside and mainly outside of Washington, engineers, academics, and CTOs from multiple facets of the industry. The first panel, and I see some of you are up here already, will examine the technology capabilities of our communications networks today and in the future, including both wireline, copper, fiber, coax, and wireless, and in the future. This diverse panel includes respected academics, including Meng Chang of Princeton and MIT's Dina Katabi, who I saw at MIT last week, or 2 weeks ago, as well as some of the vendors, CableAgs, Calix, Alcatel-Lucent, that are developing products to enable more reliable and innovative services. The second panel will examine the adoption and use of various technologies across different demographic groups. This panel will be led by a former member of the FCC family, Dr. John Horrigan of the Joint Center for Political and Economic Studies, who will both moderate the panel and provide a general overview of the current usage and demographics. We'll also have panelists speaking about the unique issues facing different demographic groups, including the disability community, rural America, the business community, as well as communities of color. Finally, panel 3 will examine the timing of the technology for the technology transition of different networks. The panelists today represent multiple facets of the communications industry with representatives from Cox, Frontier, Qualcomm, Verizon, and XO. And I want to thank all the panelists for joining us. By gathering data about the technologies themselves, the way Americans use these technologies, and the drivers for network investment and innovation, the task force will be able to help the Commission determine what policies are required in today's and tomorrow's communications networks. While technological advances can change markets, they don't change the FCC's mission. So as we move forward with this effort, we'll be guided by a set of constant core principles and priorities. First, competition. History has shown that competition is our most effective tool for driving private investment and innovation, and that smart government policies are vital for ensuring competitive markets. Indeed, the benefits and choices brought by the technology transitions exist because of massive private investment and because of policies that created and maintained the conditions necessary for competition to flourish. As these transitions move forward, they're changing communications markets, often in ways that can increase competition, particularly for voice services. But they don't automatically ensure competition. So while some like to refer to the, quote, competitive all-IP world as if competition and IP are synonyms, we know that's not true. We need to take a sophisticated, data-driven approach to determine which policies to keep for today's markets, which to add or modify, and which to eliminate, again, focusing on this core goal of competition. Second key goal, consumer protection. Consumer protection is vital because even with strong investment and innovation, even with competition policies, competition won't reach everywhere, and because even healthy markets with robust competition can leave consumers subject to abuse, we have a core responsibility. That's why, for example, we have rules to ensure access to communications technology for Americans with disabilities, to promote transparency and disclosure, and to protect consumer privacy. These are just some of the consumer protection issues that have been important and remain important even as technologies change. Consumers need to know that the FCC's got their back. Third, and closely related, universal service. The concept of universal access to modern communications is at the heart of our consumer mission and our founding statute, and access to broadband is this generation's universal service imperative. Wired and wireless broadband have become an indispensable platform for innovation, commerce, and civic engagement. To leave large swaths of this country without broadband access in the 21st century is as unthinkable as leaving millions without access to electricity or phone service in the 20th. And the fourth core principle is public safety. New technologies bring tremendous potential to improve public safety and help first responders, but they also bring some new challenges like continuity of power. Policies and industry standards need to evolve to ensure that the resiliency of our networks is not diminished as a result of technology transitions. We laid out these key basic principles when we created the task force and charged it with providing recommendations to, quote, encourage the technological transitions, empower and protect consumers, promote competition, and ensure network resiliency and reliability. These values are the compass that will guide us to the policies and maximize the benefits of broadband for the American people today and into the future. So today's workshop will help lay a sound, factual basis for that work. I'm pleased that a number of my friends and colleagues from around the country are joining us today, including Phil Jones, president of NARUC. So let me welcome all of you. I think this will be a very productive day as we continue to seek to ensure that the FCC respond in a smart, forward-leaning, pro-investment, pro-innovation way to changes in technology while continuing to preserve and promote our core values of competition, consumer protection, universal service, and public safety. With that, let me introduce my friend and colleague, Commissioner Jessica Rosenworcel. Thank you very much, and I know Commissioner Pai is here as well, and he'll be following Commissioner Rosenworcel. So thank you very much, and have a terrific day. Commissioner Rosenworcel.
Good morning. Thank you for being here for our first Technology Transition Policy Workshop. Thank you for being here so bright and early. It's Monday morning, and we've got something that passes for snow in Washington, so I hope you've had your morning caffeine. And I'll start by saying that when it comes to communications network infrastructure, we are living in a transitional time. Nothing demonstrates this like the raw numbers. About a decade ago, in 2001, we had 192 million circuit switch telephone lines. But now, more than a decade later, that number's declined by more than 40% to 107 million. In contrast, interconnected VoIP subscriptions have risen by more than 50% since 2008, and now number 37 million. And as you heard the chairman just a few minutes ago say, 1/3 of households have cut the cord entirely with their wireless phone, their only phone. When you add this all up, we have something. We have a trend. The ways consumers are choosing to connect are growing more diverse, and so are the networks over which our content and conversations travel. We're moving from the public switch telephone network to an emerging IP and wireless ecosystem. All of these things coexist today, and they are jointly responsible for carrying our communications. But going forward, we want to do more than just apply the laws of the present to the networks of the future. We want to create an environment so that carriers are confident and can invest in their networks. And we also want to create an environment so that consumers are confident and have the ability to realize the potential and opportunity that the digital world provides. So how do we do this? Well, that's actually where you come in. It's why your conversation today matters, because we're looking at this grand shift in communications technology, and we need your advice and we need your input. So as I said in my testimony in front of Congress last week and in a speech late last year, as we approach this transition, I don't think it's the time to get caught in legal minutia. Instead, it's the time for all of us, everyone in this room included, to ask big questions about the enduring values in our communications laws. So for my part, I see 4 basic values, which I appreciate the chairman has also laid out for you and picked up on. But let me list them and some of my thoughts about them in a little more detail. Public safety, universal service, competition, and consumer protection. Now let's start with public safety because it's paramount. And in the very first sentence of the Communications Act, Congress instructed the Commission to make available to all the people of the United States a rapid, efficient, nationwide, and worldwide radio and communication service in order to promote the safety of life and property. Now, in light of this directive, I think any technological or network transition must first and foremost be judged by its ultimate impact on public safety and network resiliency. But as the numbers I just shared with you demonstrate, we are migrating fast to IP and wireless networks. That means we're choosing to go without the independent electrical source that traditionally powered our copper plant. Our new wireless and IP technologies are dependent on commercial power. When that goes out, so do our connections. But as consumers switch to new networks, I don't think we need to sacrifice safety in the process. So it is time for an honest conversation about network reliability and resiliency in the digital age. It's time to ask hard questions about backup power with our new networks and how to make sure they are dependable when we need them most. And I think the communications difficulties in the aftermath of Hurricane Sandy made this point with painful clarity. Second, universal service, or I think better put, universal access, is still essential. No matter where you live or who you are, prosperity in the 21st century is going to require access to broadband. So the Commission's ongoing efforts to promote broadband deployment and broadband adoption, they're built on this simple truth. But as we transition to new technologies, we need to make it a policy imperative that no American is left behind. Third, competitive markets are critical. Competition, after all, inspires private sector investment and innovation. But competition also requires special attention to a key element of the Telecommunications Act that has made our patchwork of competitive networks work seamlessly. And that's interconnection. And it's something I hope you talk about today. Fourth, consumer protection is always in the public interest. In a transitional world, consumers rely on both old and new technologies. We need to help them understand what different technologies offer, help them make informed choices, and ensure that they are treated fairly in an evolving marketplace. So as we assess changes in the public switch telephone network, I think these four principles, public safety, universal access, competition, and consumer protection, I think they're good guideposts. They don't get at all the details. I think we're going to leave that to many of you today. But I do think they get to the heart of the big questions we need to answer, the enduring values we need to speak to, and the big responsibilities that come with setting a policy course in a transitional time. So thank you for being here today. Thank you for being such an important part of an important discussion. And with that, I want to introduce my friend and colleague, Commissioner Pai. Thank you.
Well, thank you to my friend and colleague, Commissioner Rosenworcel, for the warm introduction. I'd like to start off by thanking all of our panelists for participating in today's workshop. Last summer, I called for the creation of this task force, and so it's exciting, exactly 8 months later, to see such a distinguished group of experts helping us here at the Commission to grapple with and understand the Internet Protocol, or IP, transition. Today's workshop aims to gather data and analysis to establish a factual baseline understanding of the technological transitions that are revolutionizing the communications marketplace. I look forward to learning from these panelists as they help us reach that understanding. There are a few things, however, that we already know. Most obviously, we know that the IP transition is already well underway. Through millions of individual choices, consumers are sending a message, a clear message, about the superiority of IP-enabled networks. As my two previous colleagues have noted, only 1/3 of U.S. households today subscribe to what we used to call POTS, or plain old telephone service, over the public switch telephone network. And that number is dropping each and every year. Copper wire networks, operated by monopoly providers and providing TDM services, those services are literally becoming history. Voice over IP, or VoIP service, by contrast, is on the rise. In 2011, there were almost 37 million VoIP subscriptions in the United States. I believe that we at the FCC should do what we can to accelerate the IP transition. And so I hope that this task force will develop a holistic set of recommendations for moving forward with the IP transition, and that these recommendations will be informed by certain core principles. Yes, 4 of them. First, the FCC must ensure that vital consumer protections remain in place. If a consumer calls 911, it shouldn't matter whether that consumer is using a wireless phone, a landline, or a VoIP application. Second, the FCC must make clear that obsolete 20th century regulations will not be imported into the all-IP world. And to do that, we're going to have to repeal some of the obsolete rules that were designed for the networks of yesteryear. Third, the FCC must be able and must retain the ability to combat market failures and anti-competitive harms. Fourth, and finally, we must stay within the bounds of our statutory authority. Now, in addition to holding workshops, there's another important step that we should take to gather data. we should conduct an all-IP pilot program that will allow forward-looking companies to choose a discrete set of wire centers where they could turn off their old TDM electronics and migrate their consumers to an all-IP platform. Now, I hope that our panelists today will share their views on how we should structure an all-IP pilot program. A well-considered pilot program would enable us to make the broader IP transition with empirical data in hand. And people have a lot of opinions about how the IP transition will play out, how it's going to affect consumers. But prediction is no substitute for practice. As Albert Einstein put it, quote, "A pretty experiment is in itself often more valuable than 20 formulae extracted from our minds." In short, there's plenty for us to discuss today and in the days to come. The stakes are high. If we at the Commission get this right, then we will give the private sector the right incentives to build out next-generation networks, to upgrade their equipment, and to make more capital investment. And that, in turn, would lead to better and cheaper broadband, more jobs, and a brighter economic future for American consumers. All of this is possible if we adopt a modernized, deregulatory framework for the all-IP world that lies just around the corner. And aided by the wisdom of today's panelists, I'm hopeful that we will do just that. Thank you very much once again for participating, and go Jayhawks.
Before we get going with our first panel, we're going to have one more distinguished speaker. That is Phil Jones, who's the president of NARUC and a commissioner in the state of Washington. He's going to speak for a moment or two. Thank you.
Good morning. My name is Philip Jones. I'm commissioner at the, as the chairman said, the other Washington. I call it the real Washington state. And I flew in today to be here and on some other business, and I'm very pleased to be at this conference. Thank you for inviting me, to Sean and Rebecca, the chairman, Commissioner Rosenworcel, Commissioner Pai. I won't bore you with any details, but NARUC has set up a task force as well. I personally set up a task force last November to look at federalism and telecom. As Commissioner Pai said, we are moving to an all-IP world. We do have the 96 Act. NARUC actually published a document in 2005 called Federalism and Telecom, in which we set forth the values on which regulation should look at the telecommunications networks. I personally feel we need to update that. And so we have 7 commissioners looking at this, chaired by Orji Isiagu of the state of Michigan. We will be coming out with our recommendations this summer, so stay tuned. All of our comments, principles are published on the NARUC website, www.naruc.org. You can get them there. It's not ironic, but I think Jessica had 4, you had 4 principles, the chairman had 4. We have 8. So I'm not going to repeat the 4, other than to say on public safety, remember that these silos, these areas that we regulate are interconnected. State commissioners like me are spending a lot of time looking about reliable electric power now. Interconnected VoIP devices, both the end-use network and your device at home, if you didn't know this, rely on electric power. When electric power goes out, I'm sorry, but you can't use your end-user devices unless you have some fantastic battery that we don't have right now. So public safety issues, I would argue, rely a lot on another sector of the economy, the electric power industry, and we all have to be looking at this. So the other 4 that we're looking at are interconnection, which is tied to competition, but networks must remain interconnected on a non-discriminatory basis to ensure ubiquitous service. We're looking at regulatory diversity. Regulation should be functional and decided after reviewing multiple points of view, and I think it's very valuable that this task force look at many points of view. We believe that evidence-based decision-making is important, not to rely on anecdote, allegory, what some people call the Kool-Aid on technology, but to rely on evidence and data. And the last is broadband access, affordability, and adoption. State regulators should play a lead role or an important role in determining state requirements for broadband deployment and consumer protection. So those are the additional 4 areas that we're looking at. I look forward to a robust dialogue in the months ahead, and thank you for inviting me today.
Good morning and welcome to the first panel on technology. I'm delighted to have such a distinguished group of participants here. Before I get started, a few items of logistics, and those will apply roughly to the succeeding panels as well. We will have each speaker give a presentation, in our case of 10 minutes. Afterwards, we will be having an open discussion among the panelists and among the FCC staff present here. We also encourage members of the audience to ask questions. In order to make that most efficient, please use index card, and you can bring those up to me, and I'll try to distill those questions so that we can make best use of our time. Let me start by echoing a few of the remarks earlier on a technology perspective. It used to be that we had separate panels and workshops on wireless technology, on copper-based technology, DSL, on unlicensed spectrum, on fiber. All of those were pretty much distinct industries, distinct workshops, even to some extent distinct FCC offices and bureaus. That, among many other things, has changed. The promise, and that has been really the goal of the Internet protocol, was always an Internet, a network of networks, independent of technology. It has taken a while before that really became technology reality as opposed to textbook. But we're getting, and I believe this is one part of our transition, to the point that almost all of our networks are hybrid networks. There are very few networks that are purely copper, certainly not purely wireless, certainly not purely coax and fiber. All of those tend to be combined into one network. And one network that appears as one network to the consumer. It is no longer a voice network, a data network, a special purpose wireless network. That's taking place both for consumer communication and, as was mentioned several times, for public safety. If you look at FirstNet, that's another example of a transition to IP that enables an integrated public safety network outside the consumer space. Thus, this first panel is ideally suited to look at the network holistically. We have representatives of researchers and companies that are looking at all of those technologies. We'll obviously focus in each one on a specific set of issues that we address. Overall, we want to find out not just what works, but also what are the limitations. What are still the challenges that we'll have to face, and which of these we can tackle in the next 5 or so years. What are some of the cost constraints that we'll need to face, both in terms of initial capital expenditure as well as operationally? What are the issues we have to deal with when things don't go well? When inclement weather or other cyber attacks, for example, interfere with network operations? How can we assure, given the centrality of these networks, that these networks are resilient? All of these issues and many more we'll be discussing in the next hour and a half or so. I'm delighted to be able to welcome our distinguished panelists here. We'll start with 2 faculty, Wang Chung from Princeton University, and Professor of Electrical Engineering, Dina Katabi from MIT, who will both be talking about the wireless side. And then we'll have the Director of Solutions Marketing from Calix, David Russell, and who will be talking along with David Eckert from Alcatel-Lucent, mostly about more the wireline side, both fiber and copper. and then the first large-scale industry that has really been a hybrid network, namely a hybrid fiber coax, namely Ralph Brown as the CTO from Cable Labs, who will be addressing current and future technologies in the cable space. We also have a number of FCC staff here that will be helping with questions afterwards, Rebecca Goodhart, Sean Lev, Jonathan Chambers, Julie Knapp, and myself. And with that, let's get started. Mung, if you want to get going.
Certainly.
And there's a clicker right next to you, and you should be able to.
Is it better to stand up or to stay?
Stay. You can stay. Just pull the microphone closer.
I'm just looking for the slides because I need to see my own slides in order to know what I'm supposed to talk about. All right, now that works. Wonderful. Now I see it. Thank you. Well, good morning, everyone. Thank you, Henning, for the kind invitation. As I step out of Union Station this morning, looking at this wonderful weather, I said, what a great day to start the first day of spring break in Washington, D.C. with the snow. Some of my students at Princeton might be enjoying the beach in Miami, but then again, they won't be talking about something as important as technology transition policy, not something as challenging as technology transition policy. In fact, it's so challenging, I need to actually have that hard copy. Thank you very much. Because this switch to my face, which is not something I want to look at. Well, how challenging is this? This is mostly to wake myself up. How challenging is this? Well, I'll say it's more challenging than a teenager getting in and out of adolescence. This is more challenging than just technology. Technology transition is much bigger than technology. It is even more challenging to phase out and sunset technology than to roll out a new technology. And I'll say that the top three questions that always bothers me a lot are the following. One is technology backward compatible? And at some point, you have to wonder the decisions made a while back as they become also obsolete. What is the cost of maintaining those obsolete technologies? Another is for the benefits that is being promised to us. Are they incrementally deployable? If we deploy 10% of the technology today, are we going to get 10% or more of the benefits? And the third is, what about the cost? There's human cost, the cost of digging trenches, wiring posts, the cost of training new people. There's equipment costs, and then there's spectrum cost. And are these costs incentive compatible with all the stakeholders? If we look at the evolution between ATM and IP, between WiMAX and LTE, we see that, as on the next slide, whoever gets into this cycle will succeed in technology transition. And this cycle says that we're going to make sure that the industry stakeholders realize that there is incentive certainty and that there is a clear expected return on the investment. And then they will be willing to create a large market. They'll be willing to put their foot into this arena. And then the vendors, some of us sharing this panel, then will say, all right, then we will be willing to ramp up our production. And as the production volume increases, the cost to consumers usually drops substantially. And then you have a wide adoption because it is affordable enough. And then as the market increases, we keep looping in a good way. And whoever cannot get into this harmonization and scaling effect is going to find it very hard to transition. So if we look at LTE today, which is the focus of my 10-minute, it is great for many reasons. For example, efficiency in using the spectrum measured in bits per second per hertz, thanks to hard work by people in signal processing and communication theory. We have a much higher speed, in part because of better efficiency. It is IP-based architecture, and therefore it's a simpler one and less latency observed. It is also much better than the first three generations of wireless cellular standard in putting a worldwide ecosystem into a harmonized standard. Now, what about many other possibilities? Henning asked me two particular questions. One is, what about fixed wireless through LTE? This is a very challenging problem, and I think a lot more experiments needs to be done before we know exactly what will happen. For example, in rural area, coverage is the challenge, whereas in urban dense area, the terrain is the challenge. What about copper? And I do believe that with technologies such as vectoring and phantom mode, dynamic spectrum management, copper has this potential to be an expensive way to help with the backhaul challenge of small cell. And I'll come to small cell in a minute. But I would like to focus next 6 minutes on is on the tomorrow of LTE. Now, obviously, there will be many advances as have been planned, including carrier aggregation through LTE Advanced, voice over LTE, including turning from capacity-focused orientation to more on coverage enhancement through technology such as SON, self-organized or self-optimized network. But the biggest challenge there, I think, is the supply-demand match. Okay. The grand challenge of 1,000x over the next 10 years. And where did that come from? Well, if you double the demand every year, then 10 years later, that is 1,000 factor. That's the beauty of compound interest. Then there is also the challenge and opportunities on the consumer experience side. For example, creating new services such as M2M, including mobile M2M, such as vehicular services. And over there, it is not just about the data plane, but also the control plane, the signaling complexity. So data plane, control plane differentiation can be easily understood by a simple analogy. At the airport control tower, right, the control plane can be email, can be phone call. All right, this flight you can take off now. The actual data plane, in that case, are the airplanes themselves. And these two are vastly different technologies in that case. In this case, the technologies might be similar, but control plane optimization remains an understudied area. And then there's the consumer quality of experience, okay, what I call from smartphones to smart data. And I will show you in the next 5 minutes how the supply-demand match really tie in to consumer quality of experience. But first of all, on the supply side of capacity, I'll say the trend are smaller, denser, and wilder. So smaller means that the cell sites are getting smaller. Okay. And that introduces a lot of interesting issues, including densification. Okay. And some people say that we may have even more base stations than phones, or equal number of base stations as phones in the future. Okay. And that introduces a lot of challenges of the interference issue at the air interface, of the backhauling issues, and of mobility control. And related to that is what I call coexistence of heterogeneous network technologies in the wireless area, what I call the wilder side. If you look at this chart here, there are at least 3 very different columns. The unlicensed one, Wi-Fi, the licensed and planned deployment, with a core network that's in charge of all the network management or the control plane. And then the licensed but unplanned or underplanned deployment, such as small cell and femto. Okay. The coexistence of these present very interesting opportunities for consumers and carriers. Now, on the other side of the equation is demand. Okay. And I believe this is time to start looking seriously at smart data pricing. In other words, the future of cellular, in my mind, is not just about a faster and stronger and wider, but also smarter. By smarter, I mean that if we look at tiered sharing and reuse, as in the PCAST recommendation last year, as in some of the FCC initiatives coming out, smart data pricing is like application layer driven and user driven tiered sharing and reuse. And that's a lot of people, when they think about 5G, they think about user experience, they think about personalization, they think about application economics, they think about bridging the divide between the pipe owner and the content owner. And indeed, we already have deployed a system coming from research funded by in part by tax dollars, and taking that into creating new technologies that's being tested, for example, by our partner MTA, a rural Alaskan operator, in rolling out trial that just started March 1st, in order to bridge the digital divide through smart data pricing in that part of the country. And this is driven by what I call jobs inequality of capacity. As a professor, I have to write one equation during each talk. So this is the equation. It says that on the left-hand side, the gradient or the rate of growth of demand for wireless capacity is much, much bigger than on the right-hand side, the gradient or the growth rate of supply per dollar of investment. And that is thanks to Mr. Steve Jobs. Starting with 2007, I think people now realize that the two sides of the equation are no longer in the original order. Now the left is much bigger than the right. And all the driving factors are here to stay, from mobile video to cloud to data-hungry apps to high-resolution devices. And if you are a restaurant owner and the customer keep coming back to your buffet, doubling the appetite every month, at some point you say, I'm going to charge you a la carte. But then a smart restaurant would say, how about happy hour? Right? Because I provision my capacity based on the peak hour demand, but I can never exactly satisfy that, assuming this is a very popular restaurant. Then, during the afternoon time, nobody is here, or very few people are here. So why not create incentive for people to use that time? Okay? And that is the spirit behind smart data pricing. If you look at this chart on top, this is actually empirical data we collected from a concluded trial with Princeton students and staff last year, and reported at ACM SIGCOMM paper last year. The peak average discrepancy is very, very big, often a factor of 2 or 3. But not all is lost. If you look at the lower chart down there, you will see that on the x-axis, it is the time axis. It's the delay tolerance. Okay? Some of the applications can tolerate seconds of delay. Others can tolerate minutes, and others can tolerate hours of delay. As the heterogeneity of consumer experience widens, it is time to think hard about what can we do with that heterogeneity. And that is what we tried. And I'll be wrapping up in 2 minutes. At the Princeton trial last year, trying time shifting, skipping the details of all the research and hard work in deploying this, what we saw are 2 big numbers. One is that the peak average ratio dropped by 30%. And the other is that the total overall usage on a weekly average basis increased by 130%. That means that the carrier's cost can be reduced and revenue can be increased. And the magic can be visualized in this interesting picture, what I call flashy white space. It is not the white space that FCC has been talking about, but the white space like what you see with the fireflies at 8 p.m. in, say, I come from New Jersey, in a suburb, New Jersey home, okay? You see them, and then you don't see them. You see them, you don't see them. Over here, even on a busy street corner, during a rush hour, you can still see sometimes certain frequency time bins will have light usage indicated by white or light blue over there. And today they are wasted, and they shouldn't have to be wasted like that. And indeed, I think this is the paradigm shift I would like to highlight, is that we should stop just counting bytes and start living with quality of experience. We should recognize and further leverage the heterogeneity of applications and of network conditions to create a win-win-win. Consumers has more choices, a lower cost per gigabyte, carriers have lower cost and higher revenue, and content app providers have more engaged eyeballs. And how do we innovate there? I would say that in addition to all the focus on physical layer, we should also look at application layer. In addition to managing wireless network from the core, we should also look at end-user device as a network management tool. And I'll conclude with a commercial so that this is a complete presentation. And this is the advertisement of a free iOS and Android app developed from my lab, Princeton Edge Lab, called DataWiz. It is one of the many apps out there that can help to educate and empower consumers, what I call network management by the user, of the user, and for the users. My time is running up, and I think commercials should stop. So let me stop right here, and that would be my contact at the last slide. Thank you very much.
Thank you, Meng. Let's move right along with Dina so that we can get back on schedule.
to do anything to get my slide?
Can you wait for...
Which one did you click?
Maybe the projector doesn't like your slides.
Okay, great.
There we go. Now you're on.
Okay, good morning, everyone.
That's what
And my name is Dina Kitabi. And the question that I would like to start my presentation with is, can wireless technology replace wireline broadband in general and particularly in rural areas? So, of course, this question is very hard to answer. So what we are looking for here is not just an answer that is yes or no. We are looking into more insight. So perhaps what is technologically accurate is to say that technologically we can deliver very high capacity to a community that don't have wireline connectivity. So we can deliver this with wireless, but there are caveats. So it doesn't mean that we can deliver it to any communities. It means that what we are looking for now over the next few years is pushing the boundaries. It's like, okay, so it's a difference between the guy that is one person in the middle of nowhere versus communities that have on the edges of some form of suburbs. So keep pushing these communities further and further to be able to deliver very high capacity wireless to them without wireline connectivity. Second caveat is that it's not going to happen along with 3G or 4G. We really need to push further than that, particularly as we have just seen that the demands keep increasing exponentially. So just looking at 4G actually is not really going to do it at all. So we need really to have more advanced technology, embrace things that are really way more aggressive in exploiting the bandwidth that we have and acquiring more bandwidth for these services. So how can we do it? As I said, there are two types of approaches. One approach is to get the best of what we have, get the best of the bandwidth that we have. Can we get 10 times more data rates out of a unit of spectrum that we have? And there are many technologies that have been developed over the last 5 years that are very effective. I'm just mentioning a few here that have been developed over both in academia and research labs, like interference alignment, distributed MIMO, mega MIMO, multi-cell MIMO, 3D MIMO, all of these technologies. There are other approaches which have to do, as we push these boundaries, of course, demands will keep increasing. So we really need to reach out to the FCC also to help and by repurposing some of the spectrum, hopefully, and being able to use that spectrum very efficiently, very dynamically, not just like, okay, it's on the scale of a database that changes on a very coarse scale, but having the ability to dynamically immediately figure out, okay, so there is a spectrum that is not used in this particular area. Can I immediately detect it and use it? So let me go over these two things at a high level. So the first thing, how can we get more out of the spectrum that we have? And as I said, there are multiple technology. I'm just going to give you one single example of things that people are looking at now. So if you are looking at a rural community, so let's consider a case where that community doesn't have any wired connectivity, but it is on the borders of some other communities that may have installation of wireline. So today, this community is sitting at the edges, at the cell edge, So it's suffering. It's suffering because you have these macro cells that are very large, on the orders of, we are talking here 5 kilometers to 10 kilometers, even more. So the capacity there at that user is very low. In addition to this, there are interference at the cell edge from potentially other cells around. So today, these users are going to be very unhappy. They're not going to be able to get the Netflix at home as they are planning. However, you can turn the equation all the way around. You can say, okay, why not having all of these towers around them that are far away, so each one of them has very poor connectivity to these guys. But if they cooperate together they can actually deliver much higher rates and capacity to these guys. And perhaps many of you guys have heard the terms MIMO and know what MIMO is. But imagine, so MIMO, typically we talk about MIMO as like you have one base station and you have multiple antennas on it, or you have one device and you have multiple antennas on it. But imagine that you can have distributed MIMO. Imagine that you can coordinate your towers together so that they act like a humongous MIMO node. We know that if you can take a single base station and you can double the number of antennas on it, then you kind of double the throughput, double the capacity. Now, if you can take and coordinate a large number of distributed towers, then you can get a humongous MIMO node that has all of these antennas together. And these are some of the ideas that are now in the possible nowadays. So, for example, you can take all of these towers, as I said, and coordinate them in a technology called Mega MIMO or distributed MIMO. And if you can coordinate 10 such base stations, then you can get the sum of all of their antennas, so you get 10 times higher gains in your capacity. So these are actually not just pure theory. There are implementations. Of course, there are not implementation in the wild, in the field, but they are in the lab, and they work. So here you can see a picture of 10 coordinated software radios are each acting as a base station, and here are the results. So you can see the difference between current technologies and what I call here Mega MIMO technology, which is this coordination of distributed MIMO. And we can get to 10 times as much data rates as we get today. And these are actually 10 times data rates, not just theoretical maximum as sometimes like LTE here. It's like the theoretical maximum is great, but it doesn't mean that everyone gets it. So what I talked about so far is how can we get much more out of the spectrum that we have. But there is more. We are really looking for, hoping for the FCC that the next stage is going to also include repurposing some of the spectrum. And in that case, you really want to have dynamic sharing. You want to push dynamic sharing to the maximum, as I said, and immediately recognize that some spectrum is not used and be able to use it. Now, the problem actually today is very, very hard to look at the spectrum, at a big chunk of spectrum, what looks like on the order of gigahertz or hundreds of megahertz, and immediately be able to tell what is used and what is not used. So today, the way you do spectrum maps is that you sequentially hop from like tens of megahertz to the next tens of megahertz, and because you are hopping and sequentially trying to detect what's happening in the spectrum, it's very easy to miss the radar signal or fleeting signals. So, but if we had the technology to be able in real time to see a wide spectrum, then we wouldn't miss it. But this is not because we really have no ability to do this. We do have the ability to do this. So this picture actually is from Seattle, showing that the spectrum is very highly underutilized. This is Seattle urban area. This is from 2013, so recent, from the Microsoft Observatory. And because the spectrum is very sparsely utilized, actually you can use something called sparse recovery theory, which is, I'm sure many of you have heard something called compressive sensing. So sparse recovery, compressive sensing, all of these very new ideas that are making a difference in the way we can access a very large chunk of spectrum. And one particular member of the family of sparse recovery is a new algorithm called the sparse Fourier transform, or sparse FFT. And what's cool about SPOTS FFT is that you can acquire very large spectrum. You can acquire it by subsampling. And because you are subsampling, you can use low-speed ADC, so it's going to be fast and cheap, and it's going to be also low power. So we went ahead and used these very new actually technologies. This is from 2012, and we used it with software radios. We used 3 software radios to build a gigahertz device that can capture the spectrum. So imagine 3 software radios. Each one of them has only 50 megahertz. So a total of 150 megahertz. We can get a device that can acquire a spectrum of the size of 1 gigahertz. So 6 times larger than the sum of the digital bandwidth of all of the software radios components. And with this, we actually used it. This is not like just, again, theory. This is actual device. And we use it to acquire 1 gigahertz in the Cambridge area. And this is how the spectrum looked around MIT. This is also very recent, between 2 gigahertz and 3 gigahertz. So I only have, actually, I ran out of time, but I'm just going to take the last minute to tell you guys that really it's all about pushing the boundaries. And wireless has very big potential to deliver very high capacities to a variety of communities. But we really need to be open, and we need to push for new technologies, not simple evolution of the existing technologies. And we, of course, need pilots of these new technologies. Thank you.
Thank you, Dina. David, you want to transition to
if you could bring up the first slide, please. Hi, my name's David Russell, and I'm with Calix. And I'm going to be talking today about wireline networks, particularly non-HFC cable networks. Our perspective is on this technology transition that during the next few years, the user experience is going to define what happens on the edge. And that user experience, as you all know, is characterized by internet content, particularly video content, and that will drive the technology adoption curve. If you look at the technologies that a wireline carrier can use today in meeting consumer demand, there's 3 technologies: ADSL2+, VDSL2, and fiber to the home. During the next decade, VDSL2 is going to act as a key transition technology to the destination network. And that destination network is characterized by all operators as fiber to the home. VDSL2 is critical because it allows operators to roll out networks that are all IP-based, to put fiber deeper into the network, and to meet the consumer demands of this decade, but not future decades. In those future decades, the capacities of the copper network will be exceeded. So it's a very good transition technology. Now, if you think about what's driving this bandwidth consumption, and the first 2 speakers have spoken about that bandwidth consumption, we have 3 factors going on. Not only do we have applications that are driving that, we have demographics, in that we have people that are not heavy internet users passing away, and they're being replaced by very heavy internet users. So even if we had no net increase in the amount of bandwidth being consumed by the applications, just demographics would drive tremendous growth in bandwidth consumption. And then finally, as all of you know in your homes, if you start to figure out how many IP devices you have in your home, the number in your home has exploded over the last few years, and all of those are consuming bandwidth. So a few quick definitions. ADSL2+ is the technology that is the most widely deployed technology in the U.S. today, DSL technology. The beauty of DSL technology, and this is its real strength is that unlike cable systems, DSL technology is dedicated bandwidth to the end user. So essentially it can act as kind of a guaranteed bandwidth to that end user, unlike a shared system. But ADSL2 is being replaced, and there's a major upgrade process taking place all across the United States today to introduce VDSL2 throughout the U.S. The third technology that's important to know about is that both ADSL and VDSL have the ability to add pairs, so to increase the number of pairs, and we call that bonding. And that increases both the bandwidth as well as the loop length that you can deliver that bandwidth. The fourth key technology is vectoring. And vectoring gives you the ability, and this is a VDSL2 only technology, gives you the ability to use signal processing to lower the noise on the loop and thereby increase the bandwidth over that loop. And then finally, the last technology, and this is in contrast to VDSL2, which is called fiber to the node, fiber to the home, which can be either a passive optical network or a point-to-point gigabit Ethernet network. Fiber to the node, as I said, VDSL2 can act as a transition technology to that destination network, which is fiber to the home. Now, the rest of the talk I'll focus on VDSL2 since that's our transition technology here. But VDSL2 is a very interesting technology in that when it was developed, they decided to focus on different profiles. And those profiles are specifically designed to adapt to the specific situation that the technology finds itself in. So you can customize that VDSL2, provision it on the same footprint to wherever that technology is deployed. All of the profiles give you theoretically the ability to get 90 or 100 megabits in the downstream, but they're optimized depending on where they are in the network. Now that would be a theoretical application of the technology. And if you were to deploy ADSL2 Plus and VDSL2 in that theoretical network, these are the kinds of bandwidths you could expect without any noise disturbers. And you can see that VDSL2 is optimized for short loop lengths. And when you add a second pair, you can not only get slightly higher bandwidth, but you can also extend to a longer loop the bandwidths over that VDSL2. However, as the loop lengths lengthen, VDSL2's performance actually becomes less than ADSL2 Plus. And for that reason, all VDSL2 systems that are deployed have an automatic fallback to ADSL2 Plus, which they can use when those loop lengths or the noise in the system gets too high. Now, the problem is that I've been talking theoreticals and lab kind of results, but these networks have to exist in the real world, and in the real world, all loops have noise. And so in the VDSL2 case, you can see that actual real results, VDSL2 is probably going to operate at about 60% of the theoretical maximums that I showed in the previous slide. So instead of 90 megabits at a short distance, you'll maybe get 40 megabits. In my neighborhood in Minneapolis, CenturyLink is delivering 40 megabits to my home, but I'm only 300 feet from the cabinet. So if you were further from the cabinet, you would only be able to get maybe 20 megabits. However, I talked earlier about the technology called vectoring, and what vectoring allows you to do is actually bring those bandwidths up closer to the theoretical rates that we saw in the lab. But vectoring has some limitations, and one of the limitations of vectoring is that if you put vectoring over a binder that already has ADSL2 Plus on it, the performance of the VDSL2 with vectoring will decline and become closer to what you see in a non-vectored VDSL2 network. So when outside plant engineers design these networks and configure the bandwidths that they're going to be able to deliver, they have to take into account all the things that are already on that binder. Now, in a greenfield situation, they're not going to already have traffic, so they can deploy a VDSL2 vector to everybody in that area. But in an existing neighborhood, they have to take into account all the existing traffic in that area. So, in a greenfield, we have a situation where VDSL2 can probably perform very close to the theoretical goals with the implementation of vectoring. However, many of these same areas are the ones that operators would choose to deploy fiber to the home in. So that may limit the overall choice of VDSL2 in those areas. A more likely deployment area would be brownfields. And in these brownfields, the goal would be to use VDSL2 with vectoring for areas maybe between 1 and 3,000 feet, and then to use VDSL2 without vectoring between 3,000 feet to 9,000 feet. Another thing you'll see is that operators will increasingly use fiber to get to nodes that get them within 3,000 feet, and that allows them to optimize the VDSL2 and to prepare for their eventual migration to fiber to the home. So in summary, these VDSL2 capabilities allow the network operator to utilize this technology as a transition, but it comes with a number of limitations that they have to engineer around. Now I'd like to just close with 2 slides. The first slide is kind of a theoretical look at what the optimal technologies are as we proceed through this transition phase. And in this case, we have greenfields and we have brownfields. And you'll see that VDSL2 with vectoring is a very good choice, along with fiber to the home, to urban and suburban areas where you have very short loop lengths. Once you get out to more rural areas, that's where the fiber to the home becomes the strong candidate. And then when you get to extremely low density areas, you shift to wireless and satellite. In a brownfield, VDSL2, probably without vectoring because of existing traffic, becomes probably the better choice. And then when we get to those remote areas, ADSL2 Plus because of the long loop lengths. I wanted to give you one last shot, and I decided to do this knowing I was coming here when I was flying into Minneapolis recently. I wanted to show you a real-world example of what an exchange might look like. And so this is taken from a plane, and this would be an example of a rural exchange area. In the small town you see there, which maybe is a town of about 2,000 or 3,000 people, you'll see the area that we can serve with VDSL2. And many of the operators do this. In town, they'll use the VDSL2, and then they'll create a concentric circle around the town, which will all be fiber to the home because of the loop lengths. And then when they get out to the really sparsely populated areas, less than 10 folks per square mile, then you get into the areas where a fixed wireless or satellite would be the ideal. So I just thought that would give you kind of a visual image of the concepts we're talking about.
Thank you, David. David, number 2.
All right. Good morning. I'm honored to be here. My name is David Eckert. I'm the CTO for Fixed Networks for Alcatel-Lucent. And going to the slides up here. There we go. All right. Well, if we look around the world, governments view broadband as a necessity. It's a requirement. It's the lifeblood of the 21st century, of the information age. And while many of these broadband initiatives are not about high speed, a lot of these initiatives are actually about coverage. And the reason why they are doing this is to address certain needs of their governments or their countries. Job creation, helping close digital divide, location independence of their workers, and productivity. But what I want to spend some time today is to talk about here in the United States and looking at the challenges that our chairman has put in front of us, looking at the first goal of 100 megabits to 100 million homes, and looking at the challenges that or the technologies to help meet that challenge. And so today I'm going to talk about two topics. One is can DSL meet the needs of 100 megabits, very much what David was talking about. And the other one is an update of what type of services can an FTTH network help enable. So first question, can DSL reach the 100 megabit? As talked about earlier, yes, it can. VDSL2 is actually a very fantastic technology. It was originally standardized back in around 2005, and the goal was around 100 megabits per second. And if you take it to the lab, you can test it, and sure enough, you'll get 100 megabits. This technology also has helped transform the traditional telco operators into becoming a provider of triple play services for voice, video, and data. But as we take this technology into the real world, we actually find that we don't get the type of performance that's been promised. If you look at the way the copper is actually brought to the homes, they're in binders, and there's lots of copper pairs there, and those copper pairs create interference. And what we find is we don't get the full 100 megabits. We get closer to 40 megabits, as stated earlier. Also, the performance is actually not very predictable. Depending upon the interference, you may get more, you may get less. Well, one technology that we've been working on is vectoring. And vectoring fixes this problem. You can think of it as noise canceling headphones for DSL modems. We measure the noise, we bias the signal coming from the DSLAM, and the receiver is able actually to realize pretty much near optimal performances. So with vectoring, these lines act as if they are in a perfect noise-free lab environment, and you get the near optimal results. There's also a couple other things to note about it as well. Whether it's good lines with little crosstalk or with, we'll say, poor lines with a little more crosstalk, they actually end up with the same type of performance. In addition to that, vectoring also makes it more predictable in terms of what type of performance the subscribers will actually be able to receive. And so on this chart, we've actually taken some readings from real live networks. This is actually in the lab as well as in the field. And as you can see, we're able to achieve some very high performance. And this is, as I said, live networks. And up to about 400, I'm trying to read the slides here, but up to around 400 meters is where we can get to the 100 megabits. But as we go further and further, the performance starts to drop off. So in addition to this, we need to actually utilize bonding. And on the right-hand side, we've plotted out a chart that we believe is representative of a North American FTTN type of network and the type of coverage that can be reached. So how do we get to 100 megabits? Well, we need vectoring. We need the shorter loops. And with that, we can get to about 28 to 30% of homes with just the vectoring alone. If we want to go to around 56 to 60%, we'll need to use bonding as well. Again, this is technology that is available today. We've been doing multiple trials with over about 40 trials. We've had a number of customers that we've already working with and have signed up with, and this is technology that's happening today in 2013 to meet targets for 2020. So you can't count copper out for meeting these needs or for meeting these bandwidth, and it's an incremental upgrade from a traditional FTTN node. And as you look at going deeper into the network or going to achieve above the 60%, we'll have to go a little further with smaller type of units. I'll call this a fiber to the distribution point, 48 ports or so, and that's how you can achieve further coverage. But beyond that, we'll actually have to go even deeper with these nodes and get smaller and make the loops even shorter. Well, with that, we're actually looking at technology such as GFast. This is being standardized in ITU as we speak, and this is to achieve around 500 megabits, but on very, very short loops. But by pushing these nodes deeper and deeper into the network, there will be new challenges that we actually will be facing. It'll be increased CapEx. We'll have to figure out how we're going to power these nodes. And we'll also have to worry about the management of these nodes deep in the network. So to go even further than the 100 megabits per second, the obvious question is, why not fiber? Fiber offers a significant number of benefits. There's reduction in the OpEx and maintenance. It also allows you to move bandwidth between subscribers, so differentiated bandwidth. Longevity, unless a backhoe or a bulldozer attacks a fiber plant, it's going to be there for a very long time. And the one thing I'd like to talk about next is the ability to actually overlay multiple networks on the same FTTH network. So GPON is one of the fiber to the home technologies that are being deployed around the world, including here in the United States. And just a little bit of background about GPON. It's 2.4 gig down, 1.2 gig up, and typically anywhere from 16, 32, 64 users on one PON. And those operators who've actually deployed a residential network, they do spend money on deploying this type of network, but they're able to offer triple play services, and as they pass by the homes, they are actually picking not just one or two, but all these three services up, and they're actually keeping their customers on their network. They're retaining those customers. But as they deploy this fiber to the home network, they actually may want to they pass businesses, and they may want to offer a wireless backhaul. As mentioned before, it's possible that the number of base stations would exceed the number of subscribers. So there's an opportunity here that if operators need to have even more high-speed data, the services may be symmetric, and they may not want to actually mix the actual residential and commercial traffic on the same layer 2 network. There's a couple choices that we have. The first choice is to actually pull more fiber, which again is additional capex in the civil cost of the civil investment of pulling the fiber. And the other option is to actually use the same fiber plant, but to actually start using different colors of different colors, if I say it that way. And so between GPON, we actually created a protocol called XGPON, and XGPON was a protocol for 10 gigabits down, 2.5 gigabits up. It was more splits, more optical budget, and the benefit of XGPON was that you could actually take a GPON network today, you could actually overlay it on top of it, and it would actually be, both networks will actually operate independent of one another. And you can go to YouTube. There's some of our customers have actually done this coexistence and have demonstrated this. So we've shown that this is actually very, very possible and is actually the right way to go forward. Now in ITU today, instead of just having GPON and XGPON, we're actually now creating another protocol called TWDM-PON. And now we're actually using more and more colors of light to actually turn on or to enable multiple networks. So now on the same fiber to the home plant, you actually can have a residential network, you can actually have business network, and you can actually have a small cell network as well. Now, we talk about technical challenges. There's also other issues, other challenges that we have too, organizational and operational challenges within the operators themselves of how this will actually come to pass. But this is technology that's being developed today, and is being made available very soon. So to recap, DSL is very much capable of providing the 100 megabits of sustained bandwidth to subscribers with an FTTN type of architecture, using vectoring, using bonding. And fiber, I think it's clear that it will meet the bandwidth needs for the 2020 broadband plan, but to help hasten the return on investment for that type of network, it's wise to actually start putting different types of services on that same plant and enabling operators to generate more revenue. Thank you.
Thank you. And we'll proceed to the final presentation from Ralph Brown of Cable Labs.
Thank you very much, Henning. Thank you for inviting me today. I'm Ralph Brown. I'm the CTO of Cable Labs. For those of you who might know us very well, we're a nonprofit research and development organization that works for the cable industry. We were formulated under the 1984 National Cooperative Research and Procurement Act. And if you have high-speed broadband, digital voice, or digital video services from a cable provider, you're using technology that was developed through Cable Labs. So I thought I'd start with a little bit of an overview of hybrid fiber coax networks. This is a very abstract diagram, but it shows you the general components of a hybrid fiber coax network. First, there's a metropolitan transport ring that originates signals at the head end and distributes them over the transport ring to numerous distribution hubs. Going out from the distribution hubs are fiber networks that go to optical to electrical nodes. Those nodes serve somewhere between 125 to 500 homes passed in a residential neighborhood. And then you can see that they're downstream of that optical node are multiple amplifiers, trunk amplifiers and inline amplifiers that amplify the signal to carry it over the coax throughout the network in the neighborhood. I've also highlighted some small businesses that often are in more residential neighborhoods, and these businesses can be served with the hybrid fiber coax networks using DOCSIS technology for high-speed broadband. In addition, many of our operators are serving enterprise companies in business parks and other areas where they're directly taking fiber to those, because traditionally those areas haven't been wired for hybrid fiber coax networks. And so it's a bit of a greenfield opportunity, and the fiber capacity to those enterprises is something that's used. In addition, more recently, many of our operators are deploying public Wi-Fi access points to further enhance the broadband service, adding a mobility component to the broadband service they get at home. So when they're out in their, going about their day, they have the opportunity to take advantage of their broadband connectivity provided through their cable operator. So the hybrid fiber coax network was really designed to be a network for growth. There were many fibers that were put in place in those runs from the distribution hub to the nodes, so those nodes could be further segmented and additional services could be added. So in the past 20 years, you've seen the industry transition from a one-way analog television service to introduce digital television services, both standard definition and high definition, switch digital TV services, so for example, video on demand, switch digital video, other kinds of video services that are one-to-many or one-to-one. We also have introduced broadband internet access services that we've been talking about a lot today, voice over IP telephony services, home security services are being offered over this network, and as well managed IP cable services, for example, your television services stream to your connected IP devices in your home. And as I mentioned earlier, our members have deployed many public Wi-Fi access points, over 120,000 to date, and it's continuing to grow. And then cable operators have also providing business services, data and voice services to small, medium, and large size businesses. But it's important to point out, I think many people look at their cable operator and say, my cable operator is just like all the other cable operators, and so the services that I get are just like anybody else's. But actually, there's a great deal of variability among the cable operators. There's over 1,100 cable operators in the U.S., and there are some key hybrid fiber coax characteristics that impact network capacity that can vary. So, for example, the spectrum that the coax network was designed and built to, they're typically 750 to 860 megahertz, but actually they can vary from as low as 450 megahertz for some of the smaller systems to as much as a gigahertz. So there is a fair amount of spectrum variability that you will see. Node size is another important factor, and that's the number of homes passed that share the same view of a particular spectrum. So those are the homes that are sharing that same spectrum. It's typically less than 500 households passed per node, but it can be as high as 1,000, and so a factor of 2 there. Then the number of amplifiers that are in the cascade from the optical network can vary. Can be as low as 0. So the optical node is the last active component in the network, and it's passive coax from there. Or you could have as many as 5 to 6 amplifiers in cascade. And those affect the signal quality and the noise level that the signal will experience, and can affect some of the capacity. So each cable operator is going to assess how to optimize the deployed HFC network, whether they choose to segment nodes, whether they choose to upgrade their network to expand the frequency limits, or reduce or eliminate analog channels, which are not necessarily the most effective use of the spectrum. So you'll see many cable operators taking different approaches for how to achieve some of these goals. This is a bit of an art chart from here, but this is really to show you the evolution of the DOCSIS technology. We are on our 5th iteration today, and it's in design and development as we speak. DOCSIS 3.1. Don't ask me about our numbering conventions. I think the only thing I've been able to figure out is that odd numbers are allowed a minor increment, and everything else has to go by major increment. But this is just an example to show you how the technology has evolved since the late 90s in terms of the development of DOCSIS 1.0 with the types of services. So with DOCSIS 1.0, we were looking at broadband internet services. With DOCSIS 1.1, we introduced voice over IP. With DOCSIS 2.0, we introduced more robust and symmetric capacity. With DOCSIS 3.0, we really expanded the capacity of the network. And then with DOCSIS 3.1, we're going even further. So with DOCSIS 3.1, we're introducing technology that will enable, at a minimum, 1 gigabits per second in the downstream. But that's a minimum. As we see with DOCSIS 3.0, we had originally targeted the minimum capacity to be 4 bonded channels, similar to the bonding that we're talking about, but in VDSL and ADSL, except that it's in frequency, not in physical copper. And you are seeing technology today that's bonding 8, 16, and shortly 24 downstream channels. And we're going beyond. So you're seeing that these set a minimum, and the technology will exceed that. So what's new in DOCSIS 3.1? Well, we're using more efficient modulation and forward error correction. So OFDM and OFDMA in the upstream, and LDPC, low-density parity checking, achieves increased efficiency. We're enabling new downstream and upstream spectrum allocations, so in anticipation of opportunities to shift the symmetry of the network, allow for more upstream capacity, ability to anticipate a passive coax network where we could take advantage of even more spectrum, are all planned in the 3.1 spec. We're reusing all of the work we've done in 3.0 or many of them, and that allows bonding across not only 3.0 channels but 3.1 channels. Further, it's also adding even more energy efficient operation by varying the energy consumption with traffic load. It's backward compatible with earlier versions, so a DOCSIS 3.1 cable modem can be upgraded before the head end and coexist with older versions. So cable operators can begin seeding the market with 3.1 technology before they've actually upgraded their head end. And as Dr. Chang had pointed out, this issue of backward compatibility is one that's well recognized by the cable industry, and you'll notice that with every generation of DOCSIS, we've supported the older versions of the technology. And the specifications for DOCSIS 3.1 will be issued later this year. So in summary, cable is investing in delivering the best broadband experience possible. We're not resting on our laurels with DOCSIS 3.0. We are continuing to invest in the next generation of technology and using the latest in technology to scale to multi-gigabit speeds.
Thank you. Thank you for the diverse perspectives on the technologies ranging all the way from next generation yet to be implemented industrially wireless to more near-term opportunities in the gigabit range for hybrid fiber coax. I want to give, in a few minutes, opportunity for also the panelists to maybe follow up with questions. But let me start a little bit by asking one question that was mentioned earlier in introductory remarks, namely to talk about network resilience a little bit. And as was mentioned, we are now increasingly relying on IP-based networks, both for business operation as well as obviously for our basic functioning as individual citizens, as well as for public safety applications, 911, and coordination of public safety response. So I was wondering if any of you would like to comment on, as we develop these technologies, what we are doing, what we can do to ensure that these networks can survive both kind of the normal outages, people digging up cables and so on, as well as larger scale power disruptions, as was mentioned earlier by Commissioner Rosenworcel. I don't know who would like to speak to that. I think it affects just about everybody in one way or another. David.
I'll go ahead and take the first one. If I look at a PON network, there's a couple options that we have. There are different types of protection modes that we've actually standardized and actually have implemented. So one's called Type B and one's called Type C. Type B is typically is to protect the feeder fiber, the first fiber from the central office to the first splitter. And Type C is actually to have a full mesh or full parallel network, a PON network. And so with those type of redundancy schemes, you can actually protect against the backhoe cuts and so forth. So we have in the PON network, we've addressed that, but there is additional cost to make that happen.
Okay. Thank you.
Yeah, I was going to say with the VDSL2 technology I talked about earlier, I didn't say it, but all of that is network powered. So from a resiliency point of view, that network should be as resilient as what we see in today's network. On the PON side, I wanted to add one thing to David's comment, is that pretty much all the entities that deploy fiber to the home today will always provide an 8-hour battery backup at the customer premise. And the greatest failure mode in these networks is actually voltage differentials during lightning storms. So that, I think everybody here has experienced that most of the time when you lose your power, it's during lightning and thunderstorms. So we do provide an 8-hour battery backup to essentially get people through those most likely scenarios when their power and then their communications might be down. But that gives them 8 hours until the power comes back on.
Okay. Just to follow up on that, do you see opportunities? I mean, most of the backup for 8 hours tend to be voice only, at least for first generation systems. Do you see opportunities for maintaining backup power for more than 8 hours and for more a full-fledged network connectivity within the home as well?
Well, all I can speak to, David can maybe add to this, is in systems that I'm familiar with, they can provision the data service to also stay up for those 8 hours. So people that have PCs with battery could continue to use their data.
Yeah, I was going to add. Okay, I was going to add that the voice over IP service by cable also battery backup in the home 8 hours, but it's also recognized by the NFP as being equivalent to TDM circuit technology as well. So it's passed that muster today. And with respect to the question about providing data services, it's the same for cable in terms of provisioning what services are available in a power outage scenario. And I think there will be an increasing focus on energy efficiency in CPE equipment, so more efficient energy efficiency in Wi-Fi networks and energy efficiency in the access network as well. So I expect we'll continue to see that, which will prolong battery life in the home.
Okay, thank you. I have one audience question, which actually we have more coming, that address more the wireless side, namely, how do you see the role on the wireless side of cognitive radio in particular? I think, Dina, you mentioned it briefly, indirectly, but I wonder if you or Mang, you want to delve a little deeper.
So how do we perceive the world with respect to cognitive radios?
For cognitive radio and for spectrum efficiency, possibly deployment cost as well.
So actually, this is a very interesting question. So I think there are two things that are happening with cognitive radios. One of this is traditionally we think of cognitive radios as, okay, if the spectrum is used, then you avoid it and you look for a hole in the spectrum and you use these holes. Now, again, there is like a difference between the primary and the secondary, and if you have things even beyond the secondary. But technologically, it's possible actually to use even a spectrum that is already used without impacting the entity that is using that part of the spectrum by using MIMO across technologies that are different. So that's technologically possible. So we are going here even beyond what traditionally people thought of cognitive radios, that, okay, find the unused hole in the spectrum and lock onto that. So this is one thing. Now, of course, you want to be probably more conservative if that part of the spectrum is used by the primary. So we are talking here about multiple secondaries sharing even a shared part of the spectrum. So this is one thing. The other thing is to be able to use it very, very efficiently, very fast. So again, imagine the difference between a database where, okay, so I might update that database every now and then, and I might think that I have a service deployed in a particular region or particular area, but I mean, in the rain, it's different propagation model than when it's a sunny day. Sometimes the signal reaches, sometimes it doesn't reach. Sometimes, I mean, particularly if we are not talking about TVs, we are talking about radar. We don't really know when they are on, when they are not. So really, the next thing is to be able to do it very real time, where we are talking about on the orders of like microsecond to millisecond detection.
Okay, thank you. Do you want to comment briefly as well?
So there are at least two different parts to cognitive radio. Cognition here involves both sensing and using. And I just want to complement what Dina just talked about in terms of sensing and talk just for 1 minute about using it. Because I think it is very important to say that what application, what end user experience are you delivering, are you promising, are you generating revenue from by using these holes in the spectrum. If you cannot have a clear business case to say this is the service value I'm providing to the consumers, then who is going to roll out the service? So I think we have to be very cognitive with respect to not just the physical layer condition, but also to the application that consumers demand today. What can wait, for example? What cannot wait? What require steady speed? What can tolerate up and down swing in the speed, possibly interruption in the middle if the spectrum suddenly becomes unavailable to this particular class of users. So that using dimension, I think, has been underexplored relative to the sensing dimension and is essential.
Okay, thank you. Julie, I think we had 2 other audience questions that you might want to.
Thanks, Andy. This question was actually directed to Ralph, but I would take the opportunity to also extend it to the others. And the question was that David Russell mentioned limits on the ability of hybrid fiber coax networks to offer service level guarantees. Can you comment on the ability of cable networks to offer dedicated and service level guarantee services, particularly to business customers? And I would extend it to the other speakers as well, knowing that there are often variations in the level of service because of things like noise and distance, the things we've heard about. And Ralph, if you could kick us off and maybe we hear from some of the others.
Yes. With respect to service guarantees on hybrid fiber coax networks, with DOCSIS 1.1 we introduced a concept called service flows. And service flows can be enable the classification of a particular flow of to have a certain class of service so that it can guarantee bandwidth and access to the network. So there's a very rich set of media access controls contained within DOCSIS that can guarantee delivery to particular subscribers or particular businesses. So that is that's technically possible, and it's used for voice over IP, and it's used for a number of other services that cable operators provide, in particular to businesses that are looking for those kinds of service level agreements.
I guess I'd add to that. With a cable network, I think one of the issues is that with business services, that as they become more and more symmetric in nature and in the bandwidth needed, there is a challenge on the upstream path to actually achieve a high bandwidth there. So that's definitely one issue. But again, that's something that can be remedied. But from a VDSL side, as David mentioned earlier, it's sustained bandwidth. It's 40 megabit, 100 megabit. It's locked in on FTTH networks. We have DBA algorithms that can give the guaranteed bandwidth, but can also adjust based on the how much traffic the whole PON is using, and give up or redistribute that bandwidth appropriately.
Yeah, I would. One of the issues that I've seen is again going back to the user experience, particularly on streaming video. I think the DOCSIS parameters, and I'm not a DOCSIS expert, but the DOCSIS parameters were largely set up around kind of a bursty data service, and when you get consumers streaming multiple HD videos over the internet, then you really test these networks in terms of their ability to offer these sustained bandwidths. I think all of us who have been on cable systems know that when the kids get home from school or at night, the system can get congested. And the user experience of the DSL tends to be better as long as they have sufficient bandwidth. So I think most of the news reports and the surveys you see, cables, and the FCC's own reports, the cable was rated higher in performance than DSL, but those were largely ADSL2 plus networks or even ADSL. I think when you compare VDSL2 to cable, you'll probably see superior performance on the VDSL2 from a user experience perspective.
Okay.
I have a couple questions, I think, that are directed from Angadina, so you get exempted from the last round, but not this one. So this is from the audience. Can you talk more about expected capabilities of 4G LTE and fixed wireless, especially in rural areas that may have old DSL as the only broadband option? Their impression from the comments was some skepticism about fixed wireless as a solution for rural areas, and maybe if each of you can comment on that.
So, thinking about the existing technologies like the 4G and 3G, the problem with reaching to the rural areas is that you actually are not talking about the strength of these technologies, where you have the small cells and you can have spectrum reuse, which is like you can give you. When we talk about, for example, LTE Advanced and all of these technologies, where they tell you about the maximum theoretical capacity, which is like multiple hundreds of megabits per second. But this is all assuming that you have a small cell, very few users, and really be able to deliver at very high power to these users. Now, if you are talking these like very large cells, and then the power will go down at the edges of these cells when you are reaching. Because it's big, it's going to encompass more users, because you are not going to deploy these small cells. So, of course, that in the current format is going to basically depend. You are not going to get the same performance that we are used to. Of course, we are not even getting that hundreds of megabits per second even in the urban areas and this much smaller cells, just because we share. So we are taking another hit based on the power and reaching much longer. Now, that said, there are multiple technologies that are in the pipeline when people talk about Release 12 and all of that stuff. So it will improve the situation, but I don't think it alone is sufficient. We really need to push the boundaries even further.
I just wanted to follow up on that because it also reflects a question that was asked on a different card I got, namely, what would you see, particularly in those rural areas that you mentioned that we've been discussing, for the kinds of multi-base station MIMO, mega MIMO, as you called it? Do you see the time horizon, given that we've seen, at least in the 3GPP world, very long lead times between technology development and actual standardization, when we're still rolling out Release 9 or so, we're now on Release 12. But do you see that as something which can be done within a matter of years, or are we looking at a decade or so?
It's interesting because, like, if you think about LTE, like people started talking about it depends how you count, but it's like definitely on the order of 10 years. So we are talking about an industry that has a humongous amount of inertia and doesn't move that fast. Now, I think let me flip the question and ask the FCC, can you guys provide incentive for the industry to move faster?
Okay.
Well, I'm going to make it easy on you, Henning. I won't ask you a question. Let me just quickly address that. I think, as engineering professor, I hate to say this, but I believe that technology, in the end, is a beast of economics. If there is enough capital injection, a lot of things can be done. For example, rural area, right? What we're talking about is per square foot of deployment cost. How many customers are there? So in the end, you can have high-end solutions that are expensive. So the question, I think, back to just now is that usually when a new technology rolls out, they first look at capacity rather than coverage, usually. But there is a trade-off between capacity and coverage. Capacity is defined as the mean or median type of throughput, and the coverage as, say, 95 percentile coverage for a normal speed. So I'll say that the industry for LTE is steadily moving towards thinking more about coverage rather than just capacity enhancement. And that is moving along the right direction. And at some point, people say, here's the best configuration that can provide the kind of rural wireless access with a reasonable cost. So I think the cost equation is really a big part of this discussion. We do have the technology capability. The question is, who's going to be willing to pay for that if it stays at this cost?
This is a very good segue into maybe a question I can ask everyone, namely, do we have good knowledge on, for a reasonable next few years, on relative, both on the initial investment, and I'm talking primarily greenfield as well as brownfield in some cases, as you mentioned, deployment, and the comparison of operational costs in the field, because that increasingly obviously is also a concern for copper networks. whether you have numbers or whether you've seen studies in that, because like you said, this is all in the end a question of how much are we willing to spend both initially and on an ongoing basis for different capabilities. And I have to say I've seen beyond just kind of graphs where the y-axis is always conspicuously devoid of numbers. I have not seen much. So if you have insights as to what you've seen or what you tell your customers and what you see in terms of inherently the advantages or disadvantages of wireless coverage, which clearly also still needs backhaul to base stations, we can't quite avoid that, since I don't suspect that microwave backhaul is going to satisfy all our needs. I wonder if you can comment on that and as to what knowledge we have, what knowledge we need to acquire. Any of them?
Well, it's interesting you ask that, because later this week I'm moderating a panel on cost optimization of fiber to the home networks. And I solicited quite a few operators to participate on that panel. And in the end, I got one person from Verizon, but everybody else is from a vendor. So I would argue that might be a good question for the third panel today. But as we all know, those are cost figures that the operators don't easily give up. I have seen some from operators under NDAs, and they generally seem to be yielding the predicted results. But again, the operators have to reveal those, and I know you've requested them in the past.
Would you speculate at least on the division between kind of a hardware side, what you produce, and the actual cost once in the end? I mean, there seem to be three components, namely the civil engineering component, the digging, the stringing, the OLT component, and the consumer equipment component.
Well, I can tell you that on my panel at OFC NFOEC this week, I have one hardware vendor and I have 5 construction people.
Is that roughly the ratio that we look at?
I think that's about the right number.
Anybody else want to chime in on this one?
Yeah, I was going to say that I think what you're seeing across the panel is a rational investment that makes sense given the particular technologies that are being deployed. It's continuing to grow. I think you see the competition between the various providers attempting to try and match or beat or the services that are being delivered. So you're seeing a rational progression of the market from that perspective. So as you see in the cable networks, this continued growth in the capacity of the network and the capability of the technologies over time has just continued to advance.
And I'd also add that my customers are always asking about how they can actually monitor more of their FTTH networks, how they can actually lower the cost, and not just do it on a reactive basis, but on a more proactive basis, and actually monitor what's going on before the problem actually really happens. So our customers or my customers are very interested in how they can actually reduce a lot of their operational expenses. But for sure, for a fiber network, the CapEx part of it, the civil costs, extremely a big chunk of it, as I showed in my slides, as well as the CPE costs. There's definitely a big challenge as well.
Well, I believe in the potential of a sweet spot in this cost-performance trade-off. I believe in the potential win-win there, because I don't think we're operating either wireless or wireline yet at the efficient frontier points yet. It is very hard to operate efficient frontier, which is a concept in economics. For example, your 401k investment, you look at the average return, you also look at the variance of return. That average and the variance, you can't get the best out of both. There's a trade-off. So whenever we are not operating at the efficient frontier, there's potential to create a win-win. You get a better variance smaller variance and a higher return at the same time by moving from a less smart money manager to a smarter one. And I think that is the potential here. For example, as we see a diverse set of different consumer experience and application needed, from bursty ones to steady streaming ones, this reminds me of the pizza experience with my 5-year-old daughter who loves the cheesy center, and I turn out to love the crispy crust. So we are very complementary. So there are spectrum usage possibilities where you can have a better usage for everyone so that it becomes a win-win. And I think that will certainly accelerate the transition possibilities.
Okay. Jonathan, did you want to add any questions?
Just to follow along this same discussion about the economics of it, I think it was in a Calix presentation, you've got a grid, at least for population density, as to when it makes sense. And so just again to focus on the wireless component of that, or wireless and satellite, which is fewer than, if I recall, it's fewer than 10 persons per square mile is how you have it, and at least 2 to 10 for wireless, and then fewer than 2 as satellite. That's pretty sparse, right? That's would imply that you wouldn't see wireless as a replacement for fixed line networks, except in the most remote areas of the country in terms of population. And I wondered if it doesn't quite sound to me from what Dina and Mung are saying that that's quite the way you see it. That is, and maybe this is just a question of complementary versus substitution. But I wonder if you could speak to, as you've looked at this, is it just in those most remote areas, or do you see sort of the substitution possibilities creeping into a little bit greater density than 10 persons per square mile?
So, again, I mean, there are two components here. One of them is the business case, and the other one is the technology. And I can't claim that I studied the business case, but I can tell you that the technologically, yeah, I can see it in more in areas that are way more populated than this. And effectively, like when you asked about area, so again, there are the areas that are have very few people and very dispersed. Most likely these are going to go to satellite. It's not even the broadband that we are talking about. Then you get to areas that now it's hard to provide them with the high capacity because of the technology. But as the technology gets a push, then actually you can support much larger number of people per cell, and at a high capacity that will allow them to watch Netflix and do the stuff that they would do with a wireline. And I think that line would be pushed significantly if the technologies that are known to research labs in academia make it to the market. Now you can ask where exactly that line, at like how many people like what is the size of the town that you are looking at, or the community. Those numbers, if you want the exact number, then that has to be a business study.
Okay.
Could I add to that? I mean, I think it can be somewhat slippery slope to say at this number of density, this is the right technology. This density is another technology. You really have to look at it not on a case by case basis, but to really see the demographic, the way that network is going to be built, and the economics of it is what's critical to make a solid business case to make it happen. So, I mean, if you look even at the maps on the website, you can see a lot of rural areas covered by fiber. So it's pretty interesting.
Yeah, no, I think where AT&T, for example, and Verizon are looking at wireless substitution, they're looking at where they've got LTE networks built today, where they think they can leverage those networks, where they've got maybe older copper networks that they're thinking of replacing. So I recognize that, but the grid wasn't my grid as far as population density, so I'd maybe bring it back to...
Yeah, well, obviously there's lots of variables here. I think my position on this is that, again, going back to the user experience and the economics, if you look at the next 6 years. Are you, as a rural subscriber, or going to pay $300 a month, say, so you can stream Netflix? I don't think so. And so, the problem with the wireless substitution is everybody talks about the technology. It's wonderful technology. But unless the pricing structures change, if you're downloading 5 gig a night, I don't think you're going to do it over a Verizon LTE network in a rural area, because they can't deliver the bits for the price that you would be affordable to a rural subscriber. So we all have to keep in mind that what's the cost per bit, and my point is that for that user experience in that kind of middle density area, I think the wireless is probably not going to be able to give the operator what they want to make a business case and to meet that consumer demand.
Okay. Rebecca wanted to kind of ask one question.
When he opened his remarks about the transition from copper to fiber to TDM to IP, I didn't know if the panelists could speak sort of where you think we are in the transition. How long do you think the copper to fiber transition is going to occur, and similar with the TDM to IP?
I think to a certain extent in cable it's already happened, and the industry will continue to push fiber deeper as demand requires. And ultimately, if you get fiber to the home, then ultimately you might get there. But it's going to be an incremental investment over time, because the coax network does provide a great deal of capacity. In fact, Verizon Fios is hybrid fiber coax. It's just the coax is really short.
So it's a tough question. There's operators in the United States have gone down both approach, have done both, and for both of them it's worked out very well. They actually make good solid business cases and actually help transform their wireline businesses. So, but as we start going further and further, as the bandwidth increases, the demand increases, that copper loop will have to continue to get shorter and shorter.
I think on the voice side, I always get a little frustrated with the statistics that get quoted, because as Cable Labs mentioned, the delivery of voice in a cable system is over IP, but I, as the consumer, really look at it as a POTS service, right? It has lifeline capabilities, it has all those things I want. And I think all the vendors today, we all deliver that POTS service as IP, but you don't consider it IP. And so I think we get a little mixed up in our use of that term. So I think I don't see anything stopping the TDM to IP conversion except replacement of circuit switches with IP soft switches, and that's happening at a pretty rapid pace. I think on the copper to fiber transition, we're going to be in a 20-year cycle, and we're probably a 30-year cycle, and we're 10 years in. It's been exactly 10 years since Verizon started their Fios deployment, and we probably have another 20 years to go.
Okay. With that, I'd like to thank the panelists for all of their insights and contributions. I think we all learned a lot, and as it was clear that many of the questions, both on the research side and how we transition research ideas into practice, as well as just on better understanding the economics, still pose challenges in the year and years ahead. Some of those questions clearly make good introductions also to the last panel of the day. So, as they used to say, stay tuned for that one. We will now break for lunch. We will resume promptly at 12:30 so that we can start on time. And again, thank you so much for everybody here and also for those audience members who provided questions to our panelists. See you at 12:30. And applause for the...
Yeah, because I think we thought about 12 to 15 for me, and I wouldn't want to be more than 15 for sure. Are we ready to go? I think so. Okay. Good afternoon, everyone. We are going to get our afternoon session underway on looking at data and other things on just what's going on for consumers and people in this space. So my name is John Horrigan. I'm the Director and Vice President at the Media and Technology Institute at the Joint Center for Political and Economic Studies. I also used to work here at the FCC for a short time helping to work on the development of the National Broadband Plan. It's a pleasure to be here, and I thank my colleagues and friends at the FCC for the invitation to participate in this panel. We do have a very good panel today of distinguished leaders and researchers in looking at how consumers use technology. So we're about trying to figure out where consumers are as we think about the technological transitions that are underway. We have, as I said, a great panel here today. I'm going to just tick through the names of our panelists, and then I'm going to take a couple of minutes to open up with some stage setting on the data of what consumers do with their various consumer technologies, consumer communications technologies. So our panelists, we start with Chris Baker from AARP's Public Policy Institute. We have Jessica Gonzalez from the National Hispanic Media Coalition, Jennifer Simpson from the Accessible Technology Action Center, Peter Stenberg with the Economic Research Service of the U.S. Department of Agriculture, Andrew Brown, a lawyer with Levine, and I cannot read the rest, but I'll let you introduce yourself with your law firm. It's L and 3 Bs thereafter. LB3. And then we have on the panel staff from the FCC, which will be asking some questions and engaging in conversation. To my left, Rebecca Goodhart. We have Jonathan Chambers, Sean Lev, and Eric Ralph. So what I'm going to do before I get to my PowerPoint is just emphasize that this is a level-setting panel on data and what is going on with what consumers are doing. So we want to focus on the facts and focus less on policy issues. So let me urge and encourage panelists to remember Sergeant Joe Friday from the old show Dragnet, just the facts, ma'am, just the facts. And we'll let the policy discussions for another day for the most part, and certainly as the task force works over time, obviously the policy issues will come to light more and more. So with that, I'm going to take a few minutes to go through some slides on where we sit today with consumers and how they communicate, looking at how people use cell phones, the degrees of broadband adoption, and so forth. So if I could get my slides up, excellent. And as I get going, I'm going to just point out to my panelists who will be coming after me with slides that there's going to be a short several-second transition between when you would really want to see your slides and the slides appear. So it's not technological glitches. It's just a little delay in loading stuff up. So we won't have any worries there. So I'm going to turn toward my slides and get us underway. What I want to do today, as I've said, is look at data, at how people communicate by phone, by broadband in various ways, examine the patterns in demographic groups, and I've listed some of my data sources there, the Centers for Disease Control, Pew Internet's 2012 survey, FCC's Forms 77 report, which the data was reported in January 2013, data from the National Telecommunications and Information Administration, and some data from an FCC survey of 2009. So I will be jumping across different data sources, and when you do that, sometimes there's a couple percentage point difference on data points that you'd think would be the same. So the number for broadband adoption according to NTIA in 2010 is a little different from numbers I'll show from Pew for 2010 or the FCC from 2010. That's just a consequence of different data sources. Typically the differences are just a couple of percentage points, but I do want to alert the people who are very tuned to looking at slides closely that you'll see that discrepancy along the way. So at a very high level, we see the rise of mobile. Again, using FCC data from 2008 to 2011, there's an increase from 261 million to 298 million mobile subscriptions in the United States. This is for both business and residential customers. For interconnected VoIP, the numbers increased from 21.7 million in 2008 to 36.7 million. Retail switched access lines fell from 141 million in 2008 to 107 million in 2011. Again, this is for business and residential. I'll be shifting over mostly to be talking about residential over the next several slides, which means some of these numbers will be a little different. This is a slide I put together from my friends and former colleagues at the Pew Research Center, just looking at a very high level tech adoption trends over time among consumers, and these are for adults unless otherwise noted. So you can see, looking between 1998 to 2012, the steady rise in cell phone use in the United States, as well as internet use. Interesting that pretty much all along the way, cell phone use exceeds home internet use for Americans. And the internet use numbers include internet use of any sort, access via broadband, access via dial-up, which is more relevant in the years before 2006. Broadband at home, going from just a speck of people in 1998 having high-speed internet at home, up to what we see today, according to the Pew data, about 2/3 of Americans with broadband at home. On the far right column is the newest big thing in the space of consumer information technology, smartphones. In 2009, that 17% data point actually comes from Forrester Research. Roughly 17% of Americans had a smartphone. That number has grown rapidly in the intervening years. According to Pew, now about 45% of Americans have a smartphone. So you've seen this multiplicity of access to information really taking hold among Americans over the past dozen years. Whereas a dozen years ago, people might have had a desktop computer with a dial-up connection at home along with their landline phone, and some people with a cell phone. Today we have a whole lot more stuff and a whole lot more ways to get online. Looking at wireline telephony at home, this slide shows that we've seen the decline in the number of end users switched lines over the 2008 to 2011 time frame. Overall, number of lines falling by about 15 million between 2008 and 2011. But a lot of that coming out of end-user switched access lines, which stood at 78 million in 2008, down to 52 million in the latest data of 2011. And you've seen this tremendous growth in VoIP subscriptions at home, the majority of that interconnected VoIP, going from 19 million or close to 20 million in 2008 up to 31 million nearly in 2011. As part of all these changes, we've seen this incredible increase in the cell-only phenomenon in this country. Since we have some people here in the commission room, I can't ask for a show of hands out in internet people streaming. How many people here in the room are cell-only in their homes? You don't have a landline? Show of hands. Actually, a little less than you might expect. According to the latest numbers from the Centers of Disease Control, we have 35.8% of Americans who are cell only, meaning the only telephone access they have at home is their cell phone. And that's an incredible rise of by a factor of 3.5 from 2006. So the steady rise of cell only is certainly an important phenomenon in terms of how people communicate by voice in this country. So overall, this is just sort of a single review slide looking at the 2012 data from CDC. We have 52.5% of Americans with a landline and a wireless phone. We have just 9.4% of Americans with a landline only in this country, which is half the rate of just 4 years ago. And then finally, 35.8% of Americans are cell phone only, doubling from 2008 and tripling and then some compared with 2006. Next couple slides are going to dig into the demographics in key demographic areas that we might be interested in for the cell-only phenomenon. So the first slide is race. And you can see that for the cell-only phenomenon, the big driver, or really the most striking data point there, in my view, is Hispanics. 46.5% of Hispanics are cell-only. Blacks come in second at 37.7%, and whites are at 30% with cell only. And what's interesting about Hispanics, if you start to look across the graph or the table from 2006 to 2012, is that whereas in 2006 there was just a somewhat greater incidence of cell only among blacks and Hispanics, everyone was fairly close together. The gap started to grow, particularly for Hispanics, by 2009. By 2012, we see Hispanics very substantially leading the way in cell only compared to the average and compared to white Americans. Turning to age, looking again at the cell only phenomenon, you can see that if you're under the age of 35, more than half of Americans below the age of 35 are cell only, meaning they don't have a landline at home. It's still a fairly prominent phenomenon for those between the ages of 35 and 44 years old. The real drop-off, as you can see, occurs for older Americans. For Americans who are 65 and over, just 10.5% are cell phone only. And again, if you sort of piece together the Latino slide, the Latino data point on the prior slide with this, and given also that Latinos in the U.S. Tend to be a younger demographic, you can imagine that if you're thinking about the probability of a young Hispanic person being cell phone only, it's going to be pretty darn high. I would suggest, and without having been able to look into the crosstabs on this data, probably in the chances are 2 out of 3 or something like that. Socioeconomic status, looking at wealth. Poor Americans also lead the way in cell phone only, with nearly 52% of Americans classified as poor having a cell phone only as their means of communicating by telephone. If you're nearly poor, and again, these data are coming from the Centers for Disease Control, so they're the ones doing the classification of different strata as poor, near poor, or not poor. If you're nearly poor, you're above average in terms of the cell-only phenomenon, and if you're not a poor American, you're close to the average, but still trailing the average and well below the rate for poor Americans. One thing we wanted to do in getting a look at the data overall was take a look not only at broadband adoption rates, but also at what are the technologies people are using to go on with broadband at home. So this data point is from NTIA. It's from their 2010 survey, which found that 68% of homes have broadband. That number is a little bit higher than the numbers you might see from other sources such as Pew. But again, things are roughly in that 2/3 to 70% range for the share of Americans with broadband at home. And when you start to dig into connection types, you can see that most often people go online with broadband using a cable modem, followed by DSL, and then you start to get into the single digits with these other ways that people go online from home. 9% use the internet outside the home. 6% of all Americans use mobile broadband only or with other internet services. 3% of Americans with fiber optics. 3% still with a dial-up connection. And then 2% satellite, 2% other broadband. Overall, according to NTIA, 80% of Americans are not internet users, according to their 2010 data. Here's a comparison of rural versus non-rural Americans when looking at overall broadband adoption rates and how people go online from home. So you can see, first of all, rural Americans trail non-urban Americans, rural Americans trail urban Americans in broadband adoption by that 10 percentage point margin that you can see there. 60% of rural Americans with broadband at home. Now that's mostly a combination of three phenomenon for that lag in broadband adoption for rural Americans. One is rural Americans tend to be older than non-rural Americans, and older Americans generally have lower broadband adoption rates than everyone else. Rural Americans tend to have somewhat lower incomes on average than other Americans. That depresses broadband adoption. And then there's the availability issue. There are obviously parts of rural America where people simply can't get broadband, and that's going to be a drag on the overall adoption figures. So those three combinations are the things that pull down rural broadband adoption figures. And when you start to look at the connection types, you can see that rural Americans are much more reliant on DSL than other Americans, much less reliant on cable modem. And just as rural Americans trail by 10 percentage points for broadband adoption, they trail by 10 percentage points for overall internet adoption when you factor in non-broadband ways that people may go online. Here are a series of slides that try to bring different services and devices together in single slides just to get a sense of the sweep of devices people have in order to communicate. So this is overall national average from Pew's 2012 data that puts cell phones next to broadband, next to smartphones, next to e-readers and tablets. And you can see that for e-readers and tablets, just about 1 in 7 Americans, according to Pew's early 2012 survey, have those devices. I know subsequent surveys have shown an uptick in tablet adoption in particular, close to or maybe just a little bit above the 20% range. But you can see that people certainly have more gear with which to access the internet these days. As I said at the outset, most of the data I am using come from focus on adult Americans, age 18 and older. This slide focuses on teens, people between the ages of 12 and 17. This is hot off the presses from a report the Pew Internet Project put out last week. And you can see that 78% of teens have cell phones, 37% have smartphones, which is a big boost from 23% in 2011. And on usage, 93% of teens have a computer. For the most part, they're sharing that computer with someone else. 74% access the internet on cell phones, tablets, or other mobile devices. So teens are certainly getting socialized to on-the-go mobile access to the internet. And 25% of teens, in fact, say that they are mostly internet users, meaning they mostly access the internet on a handheld device. That's a lot higher than the 15% of adults who are mostly cell internet users. And among teens with smartphones, that 37% of teens, nearly half are mostly internet user. So if you're a teen with an iPhone or an Android device, half the time you're mostly accessing the internet on a cell phone. So this slide shows some comparisons across rural and suburban and urban using Pew data. And the key takeaway here is, perhaps not too surprisingly, is that rural Americans are lower on the usage of cell phones, broadband, and smartphones than the average. So nearly 50% of Americans, or about 50% of Americans, have a smartphone who live in urban areas. That's half again the rate for rural Americans, where we have 34% of rural Americans using a smartphone. This is for tablet devices, and the story is much the same. That slightly lower rate of adoption among rural Americans of tablet devices, 12%, against those averages of around 14% for all other Americans in the surveys. Here's a very busy slide looking at age and the adoption of cell phones, broadband, and smartphones. And again, a key purpose for putting up this slide is to help understand the differences that age make in the adoption of these various technologies. So for smartphones, again, we've talked several times about 45% being the average for smartphone adoption in the U.S. When you focus on older Americans over the age of 65, just 13% have smartphones. Similarly with broadband, 35% of older Americans have broadband at home against the average that's in the 2/3 range. Again, this is for devices and for e-readers and for tablets. You're seeing again younger Americans, particularly those under the age of 34, being the more active users of tablets and e-readers. But again, older Americans sticking more than likely to traditional ways of reading books or the newspaper, which is just to pick something up in hard copy. This is a slide that starts to get into the racial categories. And what is of note here, which is familiar to many of us who focus on technology usage patterns across racial categories, is that you have this phenomenon whereby blacks and Hispanics trail the average when it comes to broadband adoption at home. So that middle set of bars shows you that whites have broadband at a higher rate than blacks and Hispanics. Hispanics in particular with lower home broadband adoption rates at 45%, blacks at 57%. But then things flip when you start to look at smartphones. 45% of Americans have smartphones, but the number is close to 50% both for blacks and Hispanics. So that's certainly an interesting trend or interesting finding when it comes to technology use. African Americans and Hispanics trailing on broadband adoption at home, but leading the way when it comes to smartphones. For tablets, you can see African Americans slightly leading the pack on tablet computing, trailing with e-readers, with whites sort of taking the prize on e-readership in the United States. In talking about this panel, we wanted to take a look at people with disabilities, and this slide comes from the 2009 survey that was done in connection with the National Broadband Plan that looks at technology adoption among people with disabilities. 74% of those with disabilities have a cell phone, which trails the national average, which is in the mid to upper 80s. 42% of those with disabilities have broadband in the 2009 FCC survey. That was against an average at the time of 65%. And then just 18% had a smartphone, and again, compared with the national average at the time. We also wanted to probe disabilities at a more granular level. So this slide comes from the NTIA's 2010 report. The NTIA found that 37.5% of all people with disabilities have broadband at home, different from the FCC number from the prior slide, which was 42%. But this gives us an opportunity to, in part due to NTIA's very large sample size, to dig into broadband adoption among people with disabilities by type of disability. So you can see on the slide 27.9% of people who have difficulty dressing or bathing have broadband at home. 36.5% of those who are deaf or with difficulty hearing have broadband at home. Those who are blind or have difficulty seeing, 30.7% with broadband at home. I'm not going to read the rest of these data points, but obviously people in the disability community are interested in these numbers at a granular level, and this is probably the best source for it from the NTIA. And these are just the final couple slides, and we wanted to talk a little bit about the relationship between wireless and broadband. And if those of you who have heard me speak on this topic before, the data shows that for the most part, thinking about smartphones, your iPhone, your BlackBerry, your Android device, for the most part, that is an additional pathway to getting online for individuals. It's not a substitute for a home broadband subscription. So among those with broadband at home, 83% have a smartphone, showing how those things tend to go together for people. Flipping it in a different direction, for those who do not have broadband at home, the roughly third of the country who do not have broadband adoption at home, 8% have a smartphone. So for a minority of Americans, smartphone is in fact the only way they get online. They don't have a home internet subscription. They don't have a home broadband subscription. But it's not a big number. Just 8% of Americans are smartphone only. Those numbers are different when you look at racial categories, as the final couple bullet points show. Among blacks without broadband at home, 13% have a smartphone. For Hispanics without broadband at home, 19% have a smartphone. And for seniors without broadband at home, just 4% have a smartphone. So in today's environment, again, talking about a snapshot of today, not necessarily how things may evolve in the future, when you look at how consumers are behaving, if you're looking at the adoption patterns closely, the smartphone tends to be a complement to people's suite of online access assets, not a substitute for, say, a home broadband subscription. So I think that is a data point worth keeping in mind as we go forward. This, and I believe this may be my final slide, this brings overall wireless use into the picture. My prior data points where I said 46% of Americans have a smartphone was focusing obviously on the smartphone. This slide kind of totals up everything. How people go online wirelessly, whether that is using a smartphone, whether that's using a Wi-Fi connection with a tablet, whether that's using a Wi-Fi connection with a laptop. And the data point at the very top of the slide shows that 63% of Americans have at one point connected wirelessly. Now, that number is much higher for younger American adults. 88% of those between 18 and 29 years old have done that. For older Americans, it's a relative rarity. 21% have connected wirelessly. Wireless connections, again, of any sort, whether it's on a smartphone, whether it's on a Wi-Fi connection somewhere, is fairly commonplace for relatively well-off Americans, less of a phenomenon for lower-income Americans. And when you start to bring the racial and ethnicity breakout into focus, basically all the same. So whereas Hispanics and African Americans lead the way on smartphones for adoption and usage, when you start to bring in other means of going online wirelessly, which require additional technology assets, such as a laptop computer or a tablet computer, things start to even out, because African Americans and Hispanics are going to be a little less likely to have those other technology assets to go online, and therefore they're going to have fewer opportunities to go online wirelessly. So the wireless equation kind of evens out once you introduce other means of getting online wirelessly. So that covers my data-driven overview of things. There won't be quizzes later on for all the numbers that have been put up there. It's a good thing that the slides will be made available to everybody for consumption down the line. But again, I've tried to go through some data points to try to set the stage for where consumers are, and now we have a panel of experts to talk about some of the issues that matter to specific demographics in the slides that I've gone over. So we'll start with Chris Baker from the AARP Public Policy Institute, and as his slides come up, I would be remiss in saying that he is the second Texas Longhorn on this panel. I'm the first one. So.
LBJ School. All right, that came up pretty fast. As John said, my name is Chris Baker with the AARP Public Policy Institute, and I want to thank the Commission for inviting us to speak today, and John as well. Although I would note the challenge here of first of all speaking after John, who does these comprehensive panels and excellent data. So I tried to pare down my stuff so I wouldn't duplicate him. But then also not speaking on policy, which Public Policy Institute. So it is a little challenge, but I'm really grateful to be here. So I'll start hopefully. So we looked at a lot of data, and we looked at the CDC data that John mentioned, but noticed that while they broke out the wireless only for older adults, they didn't break out any of the other categories. And so we want to take a look at that. And the most recent data they had was from 2011, micro data. So we broke that out and came up with a couple charts I wanted to show you. And I think the theme of the talk here is that one is that the transitions take a while, and I think Sharon Gillette, a former colleague here, who brought up the telegram and how long it went from the first telegram was sent to when the last Western Union telegram was sent was 18 I think it was 44 to 2006 when in fact the peak of the telegram industry was in the 20s and 30s. So it definitely takes a while. And then the other point too is how exciting the broadband the benefits, the emerging benefits of broadband are for consumers. I think that comes out in some of the data, the fast-growing number of subscribers, but then also how much they value reliability, affordability, service quality to use their communications. So with that, this first chart is wireline-only households by age, and it still shows a significant number of households have, particularly older households, have wireline, use wireline only, but that is certainly shrinking. The next chart here shows, I think, would describe a lot of older adults now. The fast-growing number of adults using wireless, but they also value wireline service, and you see that by these higher subscription rates for both, and that goes to what I think John was saying about wireless being more of a complement than a substitute. So this is this is households that have wireline. Either they have wireline and wireless, wireline alone. It's the total effect, and it really shows you, how valuable wireline service is to older adults and how they want to keep it, whether or not they have wireless or not. And this is households that have wireless. So that could be cell only, or it could be wireline and wireless together. And again, this shows the increasing value of wireless to older adults. If we looked at this, 5 or 6 years ago, it would be significantly smaller. There's certainly a growing population that of older adults that want to use wireless. Okay, and then this is data from the BLS's Consumer Expenditure Survey that shows how spending has changed on telephone service, which includes wireless and wireline, in the past 5 years. And as you can see, older adults have paid or have increased their spending on telecommunications, telephone service, significantly compared to older adults. And certainly one factor, probably a significant factor of that is that older adults, again, are going wireline and wireless, so they're adding wireless to their telecom package, while the younger adults who are going, more of them are going cell only, are dropping their wireline. So I think that sort of is probably a good indication of that happening. And one reason for that, I think, is that wireless is radio service and is not designed to be, at least at this point, a perfect high quality as wireline. So this is a data from the Pew Internet Survey. It's called Mobile Phone Problems, and looks at cell owners that experience drop calls, at least occasionally or more frequently. And then it also looks at cell internet users and problems they've had with slow download speeds, either at some point or down below more frequently. The service quality is certainly an issue for wireline customers. And then also the affordability and the certainty or the transparency of the price. Local calling is not metered, so that is probably an issue as well. Then quickly into high-speed broadband. I think this shows the growing use or interest of older adults in broadband, and it also shows that the boomers, the older, so to speak, are pretty close up there to their younger colleagues in terms of use of broadband. The other thing about this is when we say broadband, what do we mean? The capability of broadband it can be different depending on how you define it, and it's hard to come up with the data about the quality of it if you don't have an accurate numbers on what it is. So this slide from the J.D. Powers sort of gets to that. I'm almost done here. So I just put down some issues that are trends that are going that will make phone service, telecommunications, internet service will ensure that it's valuable and valued by older Americans for the future to come. Aging, the need to or desire to age in place, caregiver support, and so forth. And lastly, just the growing number of older Americans over time will have a significant impact. So communications is an important part of that. Thanks.
Thank you very much, Chris. We move on now to Jessica Gonzalez with the National Hispanic Media Coalition. We're going to get her slides up and
Thank you.
Get her going.
We got the shot clock over here. I feel like we're ready for March Madness.
Yes.
Okay, well, I'm going to try to cover a very large and diverse group in a very short amount of time, so please bear with me. These are some of the data sources. I will get this post reposted with specific links to the data. I was trying to do this rather quickly. Some basic stats. Of the 308 some odd million people in the U.S., over a third are people of color. One thing that I think was important for the context of this conversation is the increasing presence of people of color in rural America. This is a slide that comes directly from the NTIA's Digital Nation report, and it shows that, unfortunately, the digital divide still persists. Native Americans, African Americans, Latinos have less access to broadband at home, less adoption of broadband at home. My colleague from the Asian American Justice Center also wanted me to note that although it seems that Asian Americans have adopted broadband at very high levels, once you dig into the different subgroups within the Asian community, that there's a different story. And so some of that data is hard to get at because most data collections are conducted in English. None are collected in the various 20 languages and dialects from the Asian community. In addition to this data, there are 1/3 of tribal lands and 1/2 of rural tribal lands have no broadband access at all. This is just some reservations about data sets in general that come from communities of color. Like I said, many are gathered only in English. Some are also in Spanish, but none, I believe, are collected outside of those two languages. A lot do a very good job of providing racial and ethnic backgrounds. Some do not, and many leave out Asian Americans and Native Americans. There's not a ton of publicly available data on landline use by people of color. And so this is just to say when we're using this data to look at trends or develop policies that we need to be very aware of the sort of discrepancies in the data. And this is just an example that comes from the Joint Center at the bottom here that shows just the differences in how English speaking and non-English speaking Latinos are using the internet and adopting broadband. This slide again comes from the NTIA report and looks at the gaps between the gaps of people, lower income people, less educated people, less likely to have a broadband at home, and blacks and Latinos are also less likely to have broadband at home. The U.S. territories are broadband starved. Over 4.1 million people live in U.S. territories, most of them in Puerto Rico. And you can see 54% don't have broadband access at the speeds defined by the FCC, 85.2 in rural territories, no access to broadband. And you can see it's a pretty scary picture on the islands. These are just some real basic slides about percent of people of color that own mobile phones. You can see here communities of color appear to be adopting at a higher rate than white folks. And some of this may overlap with some of the data that John gave, but about 34% of U.S. people do not have landlines or cell-only households. The phenomenon appears to be more likely in Latino and African American homes. However, I'll note that at the same time, low-income families, which many people of color are part of, are also more likely to rely on fixed-line voice service or dial-up internet access. This is according to a free press analysis of U.S. National Health Interview Survey data. In addition, many of people of color in rural areas rely on landlines only because they do not have access to wireless services, or landline users in rural areas are starting to experience problems with call completion to wireless and VoIP connections. Today in 2013, and I'll stop because I don't want to talk too much about rural, but some people of color in rural areas still do not have access to landline telephone service. Another chart, I think this overlaps with John, except for maybe the addition of the Asian data on percent of people that own smartphones. Another really basic chart, the bar on the left side is people who go online via their, of all internet users, the percent of people who go online via their mobile phones. And then to the right is the percent of internet users who go online with their mobile phones only. The next set of slides, the next slide seems the same, but actually this is of all people, not of internet users, the percent of folks who go online and have the mobile devices as their only internet on-ramp. You can see that Latinos and blacks are leading whites in that category. So this seems like really great news, where communities of color seem to be getting online through their mobile devices at a greater rate. We've talked a lot about the digital divide and the fact that people of color do not have the same level of access or level of adoption of broadband. But I just wanted to take a moment to pause and say that mobile is not a substitute for home broadband connections, at least not at this point. It's insufficient for a number of various very important tasks that people need to happen. Obstacles include data caps. Mobile devices do not have easy access to many websites on the internet. Only about a quarter of U.S. companies have enabled easy access to their websites via mobile devices. Sometimes there's slower speeds. It's not universally available, especially in rural areas, and the cost is also a barrier. People of color tend to pay higher monthly cell phone bills than white people. They're also more likely to use the competitive carriers T-Mobile, Cricket, Metro, PCS. And looking at the data, I noticed some trends. And this is looking across a lot of different data sets. And mind you, I think when it comes to people of color, there's at the same time there's too much data, but then not enough in certain ways. But some traits that they share, that the unconnected share, they're poor, older, they live in rural or on tribal lands, disabled, they're born outside the U.S. In terms of the Latino community, a lot of folks born outside the U.S. Non-English dominant, that's again a Latino community stat that there's no Asian data, but I would assume that would probably be, that's an assumption, I'm not going to go there, less educated, and of course U.S. territory residents. So all that to say is some of the neediest and most vulnerable people in the U.S. are some of the least connected as well.
Thank you very much, Jessica. We now turn to Jennifer Simpson. Jennifer.
Good afternoon. Am I on? Good afternoon. Thank you very much for inviting me. I'm very pleased to be here. I don't have any PowerPoint, but I'm happy to make a statement for the record if that's what you want. In thinking about the presentation here, I looked up what the future of disability would be about. And it really depends on how well America prepares for the demographic, fiscal, and technological developments that are unfolding over the next 3 decades. We know we're in a big period of change right now with the silver tsunami happening. I'm a member of that. So all this discussion about what technologies we use now, what seniors are using in the already, and what I'm going to be using, I think that's all going to shift very quickly. The 3 issues that still remain for people with disabilities, and there's 50 million of us in America, are issues such as availability, affordability, and accessibility. So availability does concern the transitions in the networks and what happens, for instance, in rural areas, and what you can access and what you can afford, and then whether or not the stuff you use with the network is accessible or not. And just a reminder, 1 in 10 incoming freshmen in college has a disability. That's how our next generation of people with disabilities in the workplace. So it's not a fixed topic, disability, and who people with disabilities are. It's constantly changing. I think you did a great job describing how incidence of disability often correlates with rural living, and ethnicity. And I just want to remind everyone how disability crosses all demographics. It also exists across the continuum within multiple domains, such as physical condition, sensory disability, sight, hearing, mental health abilities, intellectual abilities from severe cognitive impairment to autism and other cognitive limitations, across age, and across the somewhat the forgotten disabilities of multiple disability. So there's many slices to disability. It's not just a single issue that's easy to understand. We know that broadband has greatly benefited people with different types of disabilities. American Sign Language users were early adopters of video-based phone calling or video relay service. Blind people have benefited greatly from voice command systems when they use their smartphones. There are software and databases that they can access they didn't have before. People with cognitive and people with some mental health disabilities benefit from literally the faster downloading of websites, simply the less frustration. You just get to the information faster. And I think that's probably true for some of the older population members. People with disabilities, like everyone else, benefit from the free apps that they can get or the ones they want to pay for, particularly some of the ones that uniquely address perhaps their disability and give them access to information they would not have had before. That may be monitoring their health and things like that. Another group we often don't talk about in terms of the disability world is the people associated with people with disabilities among caregivers, but also physical therapists, speech therapists, and occupational therapists. With more and more connectivity, we're going to see more and more connectivity between people with disabilities and the other professionals and the paraprofessionals in their world. But overall, we like to say at the Accessible Technology Action Center that broadband greatly benefits people with different disabilities. In regard to changes in the network, we think the policy consideration should always remain what we've had so far, that consumers with disabilities expect everything to work just like everybody else does, and they want it to work with everything, no matter what the network is. We do have that principle in the statute. Section 251 has that in there. Nothing can be in the network to, bar accessibility, and it must conform with the requirements for accessibility that we already have. And there must be coordination for interconnectivity. We believe those stand there very strongly for accessibility issues. You asked what are the trends that we're seeing about the groups that we work with. There's three that I'd like to mention. One we're seeing is the bring your own device. BYOD is referred to. This could be in the workplace, or it could be in the educational environment, it could be in the kindergarten, it could be in college. This is often involving tablets, e-readers, laptops. Again, those three issues, availability, affordability, and accessibility, impact that. And we know there's problems. If a younger, poorer kid with a disability can't get it, whereas maybe the richer kid with a disability can get it, there's lots of issues around that. Another issue in the workplace is, does the IT team support maybe your customized device that you've loaded with all the accessibility stuff on it that you would like? Because it works for you, but does it work with the company's system? We're also seeing increasing wireless use by people who are blind. This is, I think, because some of the iPhone that came out was usable out of the box. This is the ideal, that it would be usable out of the box, and how to access all the information and materials you might need, particularly for your job. I think the issue of apps and how accessible they are is an emerging issue for our community. Who's responsible for making sure they're accessible? Who does the consumer go to make sure it is accessible? I think you're already quite familiar with the E911 connection issues for people who are deaf and hard of hearing, so I won't go over that one. Another issue that we're seeing emerging in the community is the IP enabling of all kinds of things that we haven't seen enabled before, such as household appliances, cars, transportation things, healthcare items, sensory things that sense your blood pressure or whatever, and it's IP enabled to be sent to your doctor, things like that. And I think this raises issues of accessibility around the controls to use those, particularly if you have physical limitations or if you have intellectual limitations. So that whole emerging trend of IP enablement I've heard of refrigerators, I've heard of all kinds of things, is really going to impact our community, I think, as we try and have controls over those and use them the way we want to productively like everyone else. Another trend that we're seeing is, obviously there's more broadband everywhere, more internet use everywhere, but the companies are using, and we focus on employment at the Accessible Technology Action Center. Companies are using systems that previously we have never heard them using before for hiring, recruiting people, the onboarding of people, in promotion, in tracking, in identifying applicants. We're seeing all these systems, even social media systems like LinkedIn, Twitter, Facebook are being used for employment recruiting purposes and to find candidates for jobs. So the accessibility of social media is starting to be a real issue in our community, whether they can even be found by the recruiters. As I hate to mention this, but we have a 12.3% unemployment rate in the disability community, which compares to the rest of the country at 7.9%. We always have a higher unemployment rate. So when we see issues around technology used in the workplace or by recruiters, which is perhaps not accessible, we say, how are our people going to be found? How are they going to use these new online telephone interviewing systems that are out there? There's a lot of little things out there we're discovering at the center that we never even heard of before. Telework is an issue. We know it's a reasonable accommodation for some people with disabilities, so we have concerns about when it gets banned in the workplace. Changes in communication technology really benefit our community, and we're really looking for the industry to be very sensitive to what we want. But we'd like to see accessibility considered on par with security, privacy, and reliability.
Wonderful, Jennifer. Thank you very much. And now to Peter Stenberg from the U.S. Department of Agriculture. Peter?
Now I'm going to basically complement John's discussion already on rural in regards to technology. And I think I've lost my slide. Okay, there. And I'm going to be talking on a little bit more different focus. It'll be on more why the internet is not being used in rural areas, or looking at who is using it and who's not using it and why. A little bit more in that category. So let's take a look at one in regards to how things have changed over time. And you can see that the internet at the beginning of a decade ago had increased rapidly and then slowed down. It continued to grow, though, over the last decade. With the introduction of broadband, the adoption of broadband increased very rapidly during the decade to where it's nearly universal in both rural and urban areas relative to those who are actually using internet. Broadband is not available, of course, in many areas, but it has increased rapidly, even in rural areas. This has not been uniformly across the country, though. There's been great variation, and this is some of what John had, for reasons what John had mentioned earlier in the other presentation. And there is differences in regards to the Deep South has always lagged relative to the Western or the New England areas, and that this occurs both in the urban and the rural areas. But I wanted to make a couple of points off of this graph, or these maps, and show you that even in some of the rural areas of the West is higher the rates than in some of the urban areas of the South. That has much to do with regards to income. Now, why households don't subscribe? This is looking at just internet, why they don't subscribe. And many people just apparently don't want it, or at least that's what they specify as their primary reason. And I want to make a point on this, is this are primary reasons, just one reason they're allowed to answer, and not saying, and they may have multiple reasons that they are not subscribing. The not too expensive is the second most common reason. They're very similar between urban and rural areas. For the reasons. Slightly more are not interested in rural areas, and then may have, from due to the age structure within rural areas compared to urban areas. As John mentioned, people in rural areas tend to be a little bit older, also a little bit less income. But also the internet subscription over across income levels varies considerably. And this again is pointing out that income or household wealth is a factor in adoption of the internet. And it's very similar between rural areas and urban areas by income level or within income groups. Though there is still a lag between rural areas or a drop-off between rural areas and from urban areas. And that has to do with regards to most likely availability. Now, broadband adoption has changed quite a bit, as I mentioned in the earlier slide. And this is, if you look at the 2007 slide, there was a major gap between rural adoption across the income levels and urban adoption. This gap has decreased over time. Broadband has become much more available in rural areas. And it's also an example of once online, people are going to adopt broadband. Dial-up just is disappearing if they can have the alternative broadband. So I want to just conclude with a number of things. Of course, broadband has been rapidly adopted across the country, and it's varied quite a bit across the country. There is a sharp difference in subscription rates across the country, and it's changed quite rapidly over the last 15 years. But there are differences, as John has pointed out, in regards to the technology. DSL is much more common in rural areas, and some of our own studies have shown in regards to the farm and community that is the predominant technology of use. We are still exploring some more research in regards to the technology and how this will be changing over time. But again, the technology is different in rural areas. Thank you.
Thank you very much, Peter. Last but not least on our panel is Andrew Brown. Do you have slides?
I do have slides,
okay,
yes.
Great. Well,
if I could get the,
tee those up and turn the floor over to Andrew.
The clicker?
Thank you, Peter.
Thank you. First, I want to thank the Commission for putting this panel together and, importantly, from my perspective, including the enterprise customer community on the panel. Enterprise customers are consumers, too. Supreme Court said corporations are people, too, or consumers, too. But we operate in a slightly different market and procure services a little bit differently than your average residential customer. And a lot of the data that John presented and that others have presented gives some very interesting trends and insights, but they're not really focused on business customers and some of the trends that affect business customers. So I want to explain some of those to you, and hopefully the Commission can use those when they start considering some of the policy issues that we're going to steer clear of today. So what are the services that large enterprise customers buy? If you look at the first three bullets, data, voice, and wireless, those are things that everybody buys and that we've been talking about. But enterprise customers buy them very differently, and they buy different versions and varieties of those services. Data services for a residential customer is basically getting access to the internet, and that's the end of the story. For an enterprise customer, it's about building a network with services provided by a service provider. And I'll look at some of the characteristics in a minute of an enterprise customer that are very different from residential customers. It's not just about access to the internet. It's about using a network. MPLS is the standard now for data networks. It's the evolution from frame relay, which preceded it, and before that, private point-to-point IP circuits, private line circuits. So what they buy is a network that they put together from a service provider, the most important component of which is class of service, which basically orders the packets in a way that ensures reliability and service availability and satisfaction of certain minimum service requirements. And that's just different from the way a customer buys best efforts internet access, which is something that enterprise customers buy, but in much smaller quantities. They also buy a lot of special access to the network, but special access is a particular form of access that business customers buy, high-speed connections to ensure that the bandwidth levels that they need are available. Voice service, also very different. Most large enterprises, if not all of them, have 800 numbers. Unlike a small business, they may have one 800 number. They have lots of them. They have features and functions associated with those time-of-day routing. So there's a lot of complexity that goes into purchasing voice services for business customers. The biggest trend right now, I think, among voice is, for enterprise customers, is something similar to what we're talking about, but qualitatively different, which is a migration towards something called SIP trunking, which is the enterprise speak for interconnected VoIP for businesses. But that is a service that is essentially moving customers to enterprise customers to a fully IP voice world, and that is, as all these trends, something that's happening slowly and over time, but is happening. Wireless services. Customers in the enterprise world buy a ton of wireless service. That growth has been as dramatic as in the consumer market for mostly the same reasons. But it is a complement to, not a substitute for, wireline services, and we'll talk about that in just a second. And that makes for very different policy considerations about what the Commission looks at when they see that they're adding on to, not substituting. Some of these other services I've listed because they're things that residential customers just don't buy. I won't go through all of them, but many of them are unregulated services that allow corporate customers to run these very complicated networks that they buy. I'll just say one thing about the last point, which isn't really a service, but a concept that people have been talking about for a long time that IP-enabled networks will certainly permit and that we're slowly moving toward, which is this notion of different kinds of devices, different kinds of access to the network seamlessly working together. It's called unified communications or fixed mobile convergence, everything on a data network. And you don't really care whether you're on a tablet or a smartphone or a phablet or whatever that big phone is now called, or a mini pad. So that's something people have been talking about for a long time, and it's something that IP-enabled networks enable. Here are the characteristics of a typical enterprise that are also sort of different from a residential customer. They got a lot of different sites of a lot of different sizes, and you've got to interconnect them seamlessly, which means they're geographically dispersed. They have different bandwidth requirements. And as a result of that, two concepts that came up earlier this morning are very relevant for enterprise customers: ubiquity and interconnection. The ability to have a service provider get you to all your sites and to have those networks interconnect seamlessly across other networks is key for an enterprise. Because they got to get to all their customers, they got to get to all their sites. Enterprise customers, some people find this somewhat surprising. They're very technologically advanced and they're always on the cutting edge of technology, but they're also very risk averse in their networks. So as a result of that, they're not implementing anything that isn't bulletproof, tried and tested. So they're not on the bleeding edge of technology in many cases when it comes to their actual network services. And that's important to kind of keep in mind because all of these things are very evolutionary in the enterprise market. Things don't happen on a flash cut. They also spend a lot of money on these services. And kind of like the government now, corporations for a long time have been required to do a lot more with as little money as possible. So even though they spend a lot, their needs have dramatically increased. So they're trying always to use technology in ways to improve efficiency and innovation, but they're always having to see some cost savings associated with that. So advances in technology that don't return cost savings aren't going to be quickly adopted in the enterprise market. Businesses, again, unlike residential customers, they buy a lot more than just a service or a technology. They buy support for that. You can't call the phone company if you're a large enterprise and say, you'll be on hold for 3 hours or, we'll get a truck to you when we can. There's a lot of support for running these networks that residential customers just don't buy. And the importance of this is there are a limited number of providers that can actually support an enterprise network. So the choice available to enterprise customers is significantly narrowed from some of the things we've seen in the consumer market. Let me talk about some trends that just don't apply to the enterprise market. Cutting the cord. We've heard some very interesting statistics about 50% of households with adults 18 to 35 are wireless only, or 34% of households are wireless only. That just doesn't apply in the enterprise market. If you are a Fortune 1000 company, the percentage of wireless-only enterprise companies is 0%. So that's my one statistic that I'm putting in here, and it's unscientifically arrived at, but it's probably right. It's just not an option. They use wireless services as a complement to their services, but wireless only is usually going to be an access issue or a complement. They're buying a lot of wireless, but not as a substitute. The second issue you hear a lot about is intermodal competition or substitution, cable for telephone service, VoIP from a cable provider. Doesn't work very well in the enterprise market because cable, for example, doesn't go. It's an availability issue to where businesses mostly are. It doesn't have the reliability and the scalability. So cable is primarily a residential play. And lastly, there are some trends that do apply. I mean, there's a huge convergence of voice on data networks. It just looks different for the reasons that I just talked about. And I will say one last thing, because someone brought up BYOD. Consumerization, which Microsoft tells me is not, in fact, a word by spell check, but we'll make it one today, gets to this concept of BYOD, people bringing their devices. And we're early days on that to see what impact that's going to have. But businesses are very conscious of it and are thinking about it. So we'll see if that becomes a trend in the enterprise world.
Well, thank you very much, Andrew. Thank you to all the panelists for a very rich set of data and observations about what's going on for consumers and enterprises with communications technology. We have time for questions, and what I thought I would do is let our expertise assembled at the table among FCC staff have some opportunities to ask some questions if there are any, or I can start with questions. I will start with questions. And certainly I'm sure there'll be more questions coming from the audience. If you have questions, please fill out some cards and I will pose them to the panelists. But a question that I'll just let the panel take a stab at, which is we've heard a lot of great facts, what people are doing, what things people have, what things people don't have. But at the end of the day, it's about how people use technology and about how people are going to adapt to this transition that is underway. So the question for myself, for all of us, I think, is what else do we need to know? Not just about adoption patterns, about which we know a good deal, but are there specific behavioral or attitudinal questions that we would want to know in order to better understand how consumers or enterprises are going to cope with a world where we're undergoing rapid technological transition? And I see Jennifer's hand up first.
I think this is one of the questions you sent us, so I did think a little bit ahead of time about changes being made in that would benefit or not benefit our community. And I think it's about things being date certain and understanding phase-in. I think when we went through the digital TV transition, it was very clear that there was a date when it was all supposed to happen by, and there was a number of activities associated with that. So I think if you're looking for recommendations around transition, you want to be very clear that if something is going to be ended or beginning, in our particular community, it's very hard for us to get the word out. Sometimes we're a very diverse community, so we need to have plenty of advance notice. And also, if there are changes that are of a very significant nature, you probably want to do phase-ins. I mean, we did phase-ins with captioning for the industry over time when we told them that they had to caption everything. So we can also do that with other things, I think, so that our communities and the people who are associated with our communities can have a better chance to understand what the transition is all about. I was just using those two as examples of, if you have hard things that have to happen, how it makes it more tolerable for our community to understand. The other thing I wanted to raise was our community, our folks often invest a whole lot in the devices and things that they use. So when everything gets changed on them, it creates a lot of frustration and also cynicism. And those are not good things, obviously, for the marketplace. So that's why I'm sort of saying that, education campaigns, awareness campaigns that help people understand transitions are extremely important.
I think that's a very interesting observation that, to me, for the observation about the disabled community prompts me to think about something Andrew said about a new model for internal support for IT and adoption issues, critical at the enterprise level, but I think it's important when you start to think about specific communities who are not as tech attuned as the rest of us may be, calling up, for certain segments of the disabled community, calling up and waiting a couple hours on the phone, that's just not going to be the model that they can.
You can't do that if you're on relay service, probably.
Yeah. And especially, looking across different demographic groups, there's going to be different degrees of friction to, let's just pick up the phone and figure out what's going on and wait on hold for a while. I think it's a challenge and a very open question as to how you adapt user support to a different technological reality. Do I see a question from Henning?
I'm going to follow up on that issue of user support because it's an area that I've worked on as well. Is one of the things that's happening is that it's increasingly seems to be difficult for users to understand who does what. It used to be when the phone didn't work, whether it was the apparatus or the line, you called the phone company. That clearly doesn't work when you have Netflix or over-the-top voice and so on. So are there models we can use elsewhere that avoid the frustration that you're being handed off between the vendor of your TV, the vendor of your service, the vendor of your wireless modem, and you spend all day in tech support hell? Are there models elsewhere in other technology transitions or in other areas, community support, in other areas that you can learn from?
What comes to mind from our community perspective has been how we had in Section 255 a point of contact designated at a company who you could at least gateway into the company on an accessibility issue. I think we sort of did the similar thing with captioning. I don't know if it extends to other consumer issues because obviously there are far more, very often, general consumer concerns than there are specific accessibility concerns. But having that available and having that well known is very useful and helpful.
Sean Lynn.
Yeah. Can you hear me? So we talked a little this morning about resiliency issues as we go through these tech transitions, and I was interested in whether the particular communities represented here had different concerns or experiences regarding resiliency of IP networks and next generation networks, and whether there are particular things we should keep in mind as we look to network resiliency disaster issues for those communities.
Sure. I think resiliency is, of course, important in all for probably all the communities represented here. I know from the storms that happened recently, people just didn't have access to communications, especially I can speak to the Latino community. There just wasn't as much communication available, especially because a lot of the communications were available in English language only. And so resiliency is a very important issue that I think we have to figure out as we make the transition. If I may, since I have the floor, just address John's issue. For us, the major trends that we think are important is just there's already so many people who are left behind right now. How do we use this opportunity as an opportunity to get those people connected, but also to make sure that the basic services that some people are just getting access to now still work?
I would agree with your points there. I would note with Hurricane Sandy, ARP did a couple state studies about responses to them, and sometimes I'll give the telecom companies a hard time, but not this time. They did pretty well in their response rates, at least comparatively to electric utilities and so forth, according to these surveys. I think that's interesting and maybe worth further study.
Let me just, again, this is maybe an example where we, in the enterprise world, have a slightly different perspective, although there's some common ground. The 911 access or the phone going out when the power goes out is not really a new concept to a business who, the PBX would go out when the power went out for years and years. So that's not a particularly new concept. It is a huge new concept for consumers and a real problem. It affects businesses in a profound way when the network overall, in other words, a lot of their customers can't get access to the network, which is the way they're doing business and buying things now. So there's a tremendous amount of concern about that. The one thing that I know the Commission is thinking about is that IP networks as such, and any technological advance, presents a great opportunity for enhanced resiliency and redundancy, and you see that in I mentioned SIP trunking, which is the enterprise class VoIP. There are a lot of ways to reroute calls very quickly that were unavailable with the prior kind of technology. So there are opportunities as well that the Commission should definitely consider.
Sean, or is it Eric Ralph with a question, and then I'm going to turn to one that was submitted from the internet.
So we've talked a little bit about who's left behind, and we've seen a lot of slides of sort of different cuts, and I know that we don't have the crosstabs, and that's exactly what's missing. But it strikes me that a lot of this data could perhaps be mined a lot better. I mean, one illustration was your slides with how the age shifts occurred. Another one is to think about what's going on that's driving, obviously we would like to know to what degree people are being left behind simply because of their incomes rather than other reasons. But there might be other things that are driving some of these differences, particularly maybe in the Hispanic community. You have people who have much more recently landed in the country or who move more frequently, and I see those as entirely different reasons. The landing more recently is a person who's sat down in a recent period of time in today's environment, made call it optimization decisions about how to set up their household. It may be that part of what we see in the age thing is less to do with part of it may literally be driven by how old you are, but part of it may be driven by the fact that, I'm pretty happy with what I've got. I sat down and optimized how to run my household 10 years ago, and I only redo it if I move house. And then I ask myself the question, do I really need this landline, et cetera? So I was just thinking both in terms of understanding who's been left behind and why, so that we can get at those issues, but also understanding where we're going. What is, where will we end up in terms of the percentage of people who are wireless only, et cetera? I think we could probably look at our data and dig down a lot deeper than we have.
I think collectively, for specific questions that the Commission may have as this unfolds, we could dig into those things and look at some of those crosstabs or look at other data resources. I think the other observation has to do with maybe thinking about new lines of inquiry that have to be undertaken in the coming months and years to understand better consumer expectations in today's marketplace. I think I have a colleague who kind of shakes her head and says people just don't care about call quality these days. Well, why? In this person's view, people tolerate dropped calls or fuzzy connections, but it's okay if they can do a lot of searches on the go with their smart device. So that's an anecdote. I think as a collective group of researchers here, we'd be happy to entertain discussions with you all to figure out what are the key questions to understand in terms of consumer expectation going forward, which will get you to different places than just the crosstab analysis, but potentially very useful ones, I think. Let me, if I may, since I have one question from the internet, get to it quickly, and then we'll turn to Henning, or I think Jonathan is a remaining person who may have some questions. This question comes from Brett Glass. His question reads, today several of the panelists have used the term wireless as if it were synonymous with mobile wireless, neglecting to mention fixed wireless as a broadband solution. MyWisp, or Terrestrial Fixed Wireless ISP, provides enterprise solutions, business cutting the cord, as well as residential broadband, all over IP connections. The service is more reliable and faster than DSL or leased lines, and the infrastructure is far more cost effective. Would the panelists care to comment on the role that fixed wireless can play in the IP transition, and in broadband adoption and deployments. Any takers?
Well, I'll be a quick taker because that question seems to come from someone interested in selling enterprise services. I wasn't using the term that way at all. Fixed wireless is an alternative, and it's in some use by some enterprises, but it has natural limitations on propagation and the way it works, and it has simply not been an effective substitute for wireline networks. It's used a lot in backup. It's being used in many cases, but let's not confuse that with a primary service that people are using in spite of wireline broadband access. So we'll see how technology has its limits, physics has its limits. We'll see how that moves along with all the spectrum reorganization, but it's not right now an adoption trend that we see in the short term.
Great. Since we have limited time, I'm going to give Jonathan an opportunity for a question.
Quick follow-up to similar to what Eric was discussing, and I know John and I talked about this before the panel began. Within the CDC data, they ask not only have you cut the cord, but what do you consider to be your primary means of voice communications? And there, if you consider both cord cutters and primary mobile users, use mobile instead of wireless, you get well over 50% of the population now considers mobile voice to be the way in which they choose to communicate. So my questions go to, again, sort of a continuation of this trend, but also to pick up on data, because the questions in the CDC data on that go to data usage. And so let me just step back. If you were to look 20 years ago or so, most people would have said that cell phone use and then the emerging PCS market was a complement to fixed line usage. That's how it was viewed. The change occurred as people got more and more minutes of use for their money. The buckets got larger, 500 minutes plus seemed to become a tipping point where people started cutting the cord. And then, as sort of Eric was suggesting, young people who didn't have to make a choice as to whether to have a fixed line home. Renters, I think you find the same kind of thing. Renters tend to be mobile only. Hispanics, same kind of thing. Immigrants, very similar to Hispanics overall. New immigrants are much more mobile only than they are fixed line. This is a long-winded way of saying, that sort of 20-year migration, and now you'd say that, POTS, maybe we ought to be thinking of something like, POMS or something, plain old mobile service. But for data, we're at a very early stage of mobile data. And especially with the last couple of years of tablet usage. So as you talk to people or as you look at surveys, might you start to see the same trends in data usage? That is, now it's a complement. It's clearly a complement now. But as people use more tablets, smartphones, might you start seeing a lot more mobile data only users?
I think you'll have to get to the same tipping point, and I don't think we know enough to know what that is at this point about data. If you're going to do a wireless only 4G home internet access plan as your anchor home broadband subscription plan today, the 4 gigabit limit that a lot of carriers impose may not do it for some households, so that will limit that transition that you're suggesting that did happen for minutes and cell phone use over the past 20 years. That could change. Business models evolve. The capacity will certainly increase and evolve. We heard a lot about that this morning. So I think it remains an open question as to how quickly that might occur, because it depends on business plans and spectrum availability or more effective spectrum usage coming online. I think today, the data just suggests that it's by and large not the anchor point for people's home broadband experience. I think we're just a good ways away before we can even hazard some guesses on that as the principal home access point for people. And I think if you think that that's going to happen in some fashion in the near term, you're going to have to figure out what else people are doing to get online. Are you in the apartment building with your 4G subscription as your main broadband or your only broadband access point, but are you going down to Starbucks? Are you being opportunistic about getting access elsewhere? I think that's a likely pattern you might see today. Might not happen in 5 years, depending on developments in the marketplace. Peter had a comment, and I think we'll need to wind up shortly there.
Brief comment, and we seem to be dancing around one thing in regards to adoption and why people adopt is what is the goal for the adoption? Is it to do some kind of entrepreneurial type activity, or is it just to talk to their grandmother? That makes a big difference in regards to what this technology change will mean and also the costs that we're going.
Sort of the what drives adoption?
What drives the adoption.
I mean, in my experience looking at data on broadband adoption, when you ask people, what do you want to do online or what's the most important thing you do online, it's communicate with family and friends. Entertainment is on the list. It trails communicating with family and friends. Usually second place is sharing information or content with family and friends, so it might be pictures, it might be video. Increasingly, a survey I was involved with for Illinois last year, asking new broadband adopters what pulls them online, there was a high incidence of people saying getting healthcare information. So consequential information searches is a big deal. To me, the answer is always plural to that question, and I've been looking at that question for at least a dozen years, and the notion of the killer app to me has always not sat real well with me, because when you look at the data, what drives people to using these gadgets and these services is the opportunity to do a lot of different things that they want to do when they want to do it.
Can I just make a point there? I mean, for some people, voice is totally unnecessary. So, you want to go to text and data right away, and to have to pay for it is useless. If you're a person without speech or deaf or hard of hearing or whatever. So, anything IP enabled starts to become what you want. You don't need to pay for it. So, I mean, that's just sort of we saw that with video relay service adoption. Early adoption in our American Sign Language community. So there's no reason to think that that isn't going to be true for other people. I myself have split my voice completely from my data. I just have a feature phone for voice. Who sits on the phone anymore? Everything now is text. So I think we're really seeing the divergence of voice and data and text in a new way, and it's going to continue for everybody, whether you like voice or not.
Kenny wanted a contribution.
This is, again, following up a notion what additional data would be useful. Looking at your presentations, one thing that struck me was there's relatively little discussion of budgets and costs for consumers. It matters in a number of dimensions, namely somebody has to invest based on revenue, and it can't just all be USF money. I'm sorry to say that. But the budget, clearly, given that median incomes aren't growing that much, at least for most individuals, has to be to some extent either a displacement of something else, or within the communication bucket, or possibly within other buckets. Maybe you buy fewer books and you buy more broadband or something like that. So one of the questions, and I don't know if you collectively have data, is as the not relevant fraction of the why don't I have internet connectivity to some extent may well be aged one. It's hard to imagine that a 20-year-old of any income would say internet isn't relevant to me. I would like to meet that person. Maybe I can introduce him to my daughter who uses the internet a little bit too much. But the longer term, that seems to be a age demographic one. But the income issues will remain with us probably for quite some time. So I wonder if it is a dearth of data that we have, in a sense it's you've certainly dug a lot into your treasure chest of data, and it didn't seem to have as much on is displacement driven in some cases simply by, well, my cable bill keeps going up, so something has to give. Landline is kind of a low-hanging fruit. Or is it one where now Communication Total is consuming a larger share of my discretionary income or my income overall? What do we know? What more data do we need? Because in the end, I think that drives both consumer adoption as well as the investment dollars that are available.
Chris?
First, I would say I don't think it's an age issue necessarily as a exposure issue. And having, if you're in the workforce, if you're using it all the time, you see the consumer benefits towards that. To your other question about spending, the Wall Street Journal did a piece of looking at consumer expenditure survey data ways back and found that over the years, while consumers had cut spending on entertainment, on food, on a variety of things, their spending on wireless plans had gone up. And in a way, communications is so important for a lot of people that might be one of the things they may scrimp on their medicines or whatever to be able to talk to their grandkids or whoever. If you 5 years ago, you might have, to go back to my other issue, you might have said, I can't imagine seeing older people on Twitter or on social media, and now, there are a significant percentage of the folks that use that. So I think it's over time, the adoption of it. And the National Broadband Plan looked into this and recognized that affordability has a relationship to relevance, which has a relationship to digital literacy. And, if something's more affordable, it becomes more relevant. If something's more relevant, you may be willing to spend a little bit more for it. So those are important, I think.
I just want to say this is a huge issue for communities of color, and I did speak about cost a little bit as one of the, people are making hard choices about what they want to buy in terms of communications packages, and for some families it is coming down to scrimping on food or making choices that I don't think we want to see people making, and so I think that has a lot to do, and I think there is data out there about that.
And I'll just make an observation on the point particularly about communities of color and things that prevent them from adoption. If you look at Hispanics in particular, cost is the main reason that that group says they don't have broadband at home. It's a younger demographic, so to your point, they are younger on average. They understand the relevance, but cost is the big deal. And then I'll just have get on my methodological soapbox for half a second on the practice of asking to people on the telephone, what's your main reason that you don't have broadband? And if that's one question and you don't have it, you're just going to throw out an answer and it gets categorized into, well, it's not relevant to people. I mean, that is in fact how these things work when you're doing the surveys. What we did for the broadband plan was basically allow people to check multiple reasons for not having broadband, get the reasons in their head, and then follow up with a question that says, well, what's the primary reason that you don't have broadband at home? The results of doing that shrinks the relevance number dramatically. Lots of people say it's not for them when they're given the opportunity to choose more than one reason. But when you then, on the second take on the question, what's your main reason, as we found in the broadband plan work, cost rises to the top, which includes both monthly fee but also the cost of equipment, computer access. And then digital literacy comes in next, relevance comes in third. So I tend to bristle a little bit when I see the single shot question on trying to understand reasons for non-adoption. You need to do a little bit more in the survey, which gets you, I think, a more nuanced understanding of the phenomenon. And I see Andrew pining. This will be the last word. We've cut into the break to some extent, but I'll let Andrew.
Let me just say that the cost, it's not so much about adoption because enterprise customers don't really have a choice about whether they're going to be online or not. But cost is a huge driver in their ability to innovate or move resources away from their core businesses to the telecommunications that they have to buy. So cost issues are always a factor in enterprise customer decisions. And that's why it's so important for the enterprise community to have competitive choices for all the different services they use, and why that is kind of a mantra that the more choices they have, they'll be able to drive costs down, innovate, create more jobs. So it's a huge issue not just for people adopting on the consumer side, but on the enterprise side as well.
With that, we have cut into the break. Let me thank the panelists for their time and intelligence and thoughtfulness today, and thank our friends at the FCC for having us here, and for the wonderful questions from the assembled expertise from FCC staff. So we will conclude.
Thank you, John.
Oh,
thank you
well,
very
thank
much.
you. My pleasure. We will conclude at 2:30. We reassemble for the final panel of the day on some of the business perspectives. So thank you all very much.
Our third and final panel for our workshop today. I want to thank everyone for coming. This panel will focus on the timing of different technological transitions, looking at different types of networks. So my name is Rebecca Goodhart. I'm going to be moderating the panel. Briefly introduce the panelists and my colleagues at the table, and then we will have each panelist give a presentation of 8 minutes, followed by a discussion with the audience and online. For those in the audience, we have cards that you can fill out and bring to me, and we will try to ask them. First, we have Tom McGuire from Verizon, Michael Golub from Frontier, Matt Grobe from Qualcomm, Randy Nicholas from XO, and John Civiletto from Cox. With me is also Sean Lev, Henning Schuldrein, and Jonathan Chambers. So with that, we will start with Tom McGuire.
Thank you, Rebecca. Thank you for inviting us here today. I thought I was going to take the award for the shortest presentation, and then Jennifer had 0 charts, and it's kind of tough to beat that. So, anyway, today I'm going to focus in. I know we opened up the session this morning talking about 4 key elements: competition, consumer protection, universal access, and public safety. And hopefully I'll be able to address each of those as I go through some of the things that we're doing today to transition our networks for our customers. Today, what I'm going to talk about is primarily focused on consumers and small business. I'm not going to get into too much about the enterprise network, and I'm going to try my best to steer clear of exactly what's going on from a statistical perspective and talk more along the lines about what's happening from a customer experience. So looking at the first slide, I think we discussed this quite a bit. Dr. Horgan did a very good job this morning, or just a little while ago, talking about all the different statistics from either the CDC or the FCC or other folks that have looked at what's happening in the network today. But I think it's pretty apparent that customers have a ton of choices available to them today. And regardless of whether or not we're ready for this transition, it is in fact happening. And if you look at some of the statistics, for example, like the 105% wireless penetration, I think it's pretty clear that people are adopting different ways to interact with each other. And we are faced with the issue of cord cutters now, but I think we also have to be mindful of the fact that there could be cord nevers on the horizon. And if I look at my own family, I could see examples with my kids of individuals who, do not rely on wires to communicate with each other or to view content or whatever it is that they want to do. The other thing that's a bit of a reality in the telecom world today is that the copper network is pretty limited when it comes to what it can do to satisfy the requirements of the future customer. Bandwidth capacity, as we've discussed a number of times, is critical. Speed, I think, will also equally be critical. And Jonathan asked a question a little while ago about that inflection point at which more people start to adopt bandwidth. And I think that inflection point is driven by not only price, but also by the devices and the ease of which these devices work. That's going to allow different people, regardless of the age or demographic groups, to adopt more bandwidth. So that's something I think we need to be mindful of as we look towards what network do we want to use today. The last reality I wanted to point out is that the traditional copper network is aging. Much of it has been in place for decades. Some of it even predates my joining the company a number of years ago. And if I go back to basic high school science, it's a metallic network And its strength, I think, is also its weakness, because once you take a metallic network and you introduce water and oxygen, you're going to get service disruptions, noise, and other things, which really kind of get to the whole network resiliency issue, I think, that Sean Lev asked a little bit about ago, and also the stuff that Jennifer Simpson mentioned as well. Resiliency to me is not only about working during a power outage, it's just working on an everyday basis. And I think, as we look at some of the alternatives we have open to us today, I think it's critical to kind of keep that stuff in mind. This next slide I threw in there just to give an indication. It's really a sort of a graphic that represents where we're headed in terms of bandwidth consumption. The chart, the lower portion, the light blue portion of the chart represents our copper bandwidth network, and our fiber bandwidth network is represented by the darker portion of the chart. And as you can see, bandwidth consumption has grown significantly since September of 2002. The thing that's kind of interesting is the chart I used towards the end of last year at a NARUC presentation, and this particular chart does not even reflect the launch of the iPhone 5 or the iPad mini. And again, I think it gets to all those, if you look at the different noteworthy events that are captured on this page, it's a bunch of different things that are changing the way people draw on bandwidth. And I think this is something that's going to continue to grow significantly as we move forward. So given this, I think it really kind of plays into our decision of, if we're investing in a network, what is it that we're going to invest in? And I don't think copper is the answer. So in any event, what we came up with is, and this is born out of being in the field a couple of years ago. I was out with a few individuals, and we're trying to correct a service problem in a copper network at a customer's house. And the thing that struck me is that while we were trying pretty much unsuccessfully to come up with a suitable pair to serve this customer, we were literally standing on top of a piece of fiber that was bypassing this customer's house. So at that time, we decided to leverage that fiber to provide the POTS service to this individual. Up until this point in time, we were using fiber primarily as a service platform for our Fios suite of products and services, which is typically viewed as a triple play. But we realized that given the technologies, we could also use fiber to deliver a plain old telephone service to people. Now, leveraging that particular investment would allow us to save money on maintaining copper in that particular area, and it would also drive increased customer reliability and satisfaction. So last year we started moving people over, and by the time the year was over, it was somewhere in the neighborhood of 250,000 people that we transitioned off of a copper network onto a fiber network. And we did that by focusing primarily on people who had, up until that point in time, a history of trouble on copper. While we saw that program was successful, the one thing that kind of struck us was the fact that our success was limited by the amount of fiber that we had out in the field. And so therefore we started looking at to see what we could do to help individuals that did not have fiber in their backyard. And we started focusing on our wireless voice network, specifically the 1X network. And we started working on a device which is called VoiceLink, which essentially emulates copper dial tone for a customer. One of the things as we focused on this entire transition that we thought was critical was the need to match the features and functionality that a lot of our customers rely on today. For example, E911 or TTY capabilities. So we came up with this device, and it's a simple little element that we attach in a customer's home. We isolate their outside plant, the troublesome outside plant, from the inside wire. And this essentially lights up all the jacks in the customer's house. And when they pick up the phone, they will hear dial tone. When they dial 911, unlike other devices, it will give the PSAP the exact address of the customer. So this way, in case emergency services had to get to somebody, they would know where to go. Essentially, if you were a traditional copper POTS customer and we snuck in there in the cover of darkness and yanked out the copper drop wire and placed this device in there, you wouldn't really know the difference. The big difference in my mind is that you would not have the same troubles that you had with the copper service up until that point. The other thing I think is pretty novel about this, and it gets a little to the resiliency part, is that there are no wires attached to it. And in the wake of Sandy, one of the biggest issues that we had to deal with was going out and putting all the wires back up that were knocked over by trees. And in this case, you don't have to worry about that. Now, the other thing that this thing does, that one of the issues that was raised as we transitioned customers off of copper and onto fiber was the 8-hour battery backup, which we talked about during the first panel. Just as an aside, we're working on an expanded battery backup, one that is customer friendly in that they'll be able to use commercially available batteries to control however long they want to have their optical network terminal up and running. We've leveraged that in this particular device. The original version of this came with a 36-hour battery backup, but we work with the manufacturer, and this particular device works off of plain old AA batteries. With the version I have in my hand, these are regular store-bought AA's. They'll give you 36 hours of battery backup. And the thing that's interesting, it'll give you roughly double the amount of talk time as the rechargeable version. So by my calculation, if you have a 12-pack of batteries from your local drugstore or big box hardware store, you'll be able to have 6 days worth of battery backup. So from a resiliency perspective, I think it's pretty good. The other thing that I wanted to touch upon just as a closing statement, I think the work that we've done has been very focused on the customer's experience. But one of the things I think is critical to the success of this or any other sort of transition program, just to echo the comments from the last panel, is customer education. We've run into a lot of individuals who have been hesitant to move over to a new platform. We're not changing their service. We're not changing the pricing. As a matter of fact, when it comes to voice link migrations, we're actually looking at some packages that are going to cost the customer less. None of these migrations cost the customers anything to actually move, and their monthly pricing could never be any more. So from a financial perspective, the cost is the same. From a service experience, the cost is the same. I think this is just a natural hesitation for some individuals to change the way they receive service today. So I think one of the things that we really need to focus on as an industry is an education process where we could start to let people know this isn't necessarily a bad thing. This could actually, from a service perspective, help them out in the long run. Thank you.
Thanks, Tom. Michael?
Hand me the clicker.
Oh, sorry about that.
Thank you, Rebecca. Appreciate that. So I just want to spend a couple minutes talking about Frontier and our challenges with moving our network forward. So Frontier, if you look at just some facts about Frontier, one of the kind of the overarching things that we need to consider is we have about 26 customers per square mile across our network. So not the density, although we have a few markets that are dense, but primarily we're in rural, very rural America. So our challenge is how do we leverage and make that conversion to an IP network in very rural America? So some of the things that we're trying to do, I think similar to just about everybody here on the panel or that has talked earlier today, is the capability to deliver all services over a common pipe, all applications over a common pipe. How can you be as efficient as possible? Just like the airlines, they're trying to fill every seat. When we build broadband, we're trying to fill that pipe with enough revenue to justify, especially in rural America where it's very costly for us to build out. We want to be able to be flexible enough. We don't know what the next application is. We had a couple smart scientists up here this morning, and whatever they're thinking down the road, we don't know what that application is. I mean, right now, if you look at Netflix and it's driving the network, but I'm sure that in 3 or 4 years it'll be something different than that. The one thing you can count on is that change. I think for us, we're looking at deploying fiber. I would love to deploy fiber to the home. To the farm in our case, but we're not going to be able to afford that. There's just not the payback in that model to be able to do that. But certainly we want to deploy it to our DSLAMs in our network, and where we're in the suburban markets, we want to be able to deploy that to the curb and then leverage the copper network from that area. It's very important to us, and as all public companies, is that total cost of ownership. To drive the model that gives us a payback. When we invest in the network and we sink our precious capital into that network, we've got to look at 5 to 8 years out and being able to make sure that what we're putting in the network today is going to service us that long, because to come around and redo these networks again is extremely costly. Managing traffic on the network, being able to proactively manage traffic on the network so that we can be as efficient as possible to optimize that traffic on our network. And then finally, leveraging the existing equipment we have, we're trying to squeeze, frankly, every last drop of blood out of that copper network where we can, because, as just was stated, copper goes bad and it needs to be replaced. But as long as we have that copper and we have good pairs in the network, we're going to continue to leverage those. So I got a specific example. I thought it would be, important to understand what we think it's going to take us at Frontier and able to transition this network. So as you look today, the top portion of the slide, is this really our current copper-based ADSL 2+ network that's out there? And it's got, a lot. It's got ATM boxes in it. It's got the copper. It's got the DSLAM in it. And when you look at, changing over these networks, you really have to look at end-to-end. From our national data backbone, where we peer with companies like Verizon and AT&T and others, all the way down to the home, in order to consider how do we modernize this network. And as we move forward with this IP network, you can see from the bottom slides that many of these pieces of equipment come out of the network. It becomes more efficient. We drive fiber as deep as we can into the network. In this case here, I demonstrate DSLAM. Was talked about voice over IP. So now we have a switching room that's probably half the size of this room with an old Nortel DMS 100, and we replace it with a VoIP gateway that takes up one rack of space. So it's just iteration of building this network to bring it forward. I think one of the things that often gets overlooked as we talk about this, the first part of this, and being an engineer, I love to put new shiny equipment out in the network. But the real challenge, I think, for all of us is the back office support systems. So we have a provisioning system for TDM. So now we're running dual systems. It's not only dual networks of the copper network or the fiber network or a TDM switch versus a VoIP switch. It's also the provisioning system. So many provisioning systems, you have to buy a broadband module to be able to do that. So now you're paying cost on those. Separate equipment management systems that you have to have in order to do your TDM process or your IP process. So the quicker you can move to an all IP network, it takes some of these costs out of the business. But then there's the staffing and the training. So as our veteran workforce leaves us and retires, we hire a new engineer or a new technician that comes in, and we've got to send him to train him on a Nortel DMS 100 because that person's gone, and we still have those in the network. And that's very costly. Plus, we know that's not where we want to go. That's not our vision of where we want to be. But at this point, doing this transition, you've got to be able to train that. And so you've got to have employees that know the TDM network and know the IP network. And those are different skill sets. And some people can make that migration, but a lot cannot make that migration to the new technology. So whether it's in your network operations centers, whether it's in your provisioning centers, or whether it's in your field forces, you've got to be able to look at both of those technologies and make that graceful migration. And then the older equipment, it's dying. There's pieces of equipment that we have on our network, like many others, the only way that you can get spare cards is to send them off and have them basically remade from scratch. And so we're going to have to move this network, I think, as you said, whether we like it or not, we're going to have to move this network forward, and we really don't have a choice. It's how can we do it, take care of the customers at the same time, and do it cost effectively also for our shareholders. Thank you.
Thank you. Michael. Matt?
Thanks. Glad to be here today, and I'm looking forward to talk to you about the evolution of wireless and how we're going to provide a lot more performance and capability than we have today, up to 1,000 times more. So the first point is, this kind of echoes what my fellow panelists have been saying. There's a transition to wireless in households, and it's getting it's really taking off. I can tell you from personal experience, I've got family members now living in a small town in Illinois that have turned off their wire lines and have gone completely wireless. And this trend is just accelerating. There's more and more of it. The question is, what happens as time goes on and the networks become more and more loaded. So we look at not only the conversion of wireline services to wireless, but the explosion of mobile services, and we try to decide how are we going to engineer the networks for the future? Where do we need to set the bar? And there's a lot of statistics that tell us that we need to brace ourselves for something on the order of a factor of 2 every year for maybe the next 10 years. AT&T in particular, as an example, their network has gone up. The mobile data network usage has gone up 250 times over the past 4 or 5 years. So we look at how we're going to do that. How are we going to handle that kind of load? And the way we're going to do that is with a combination of approaches. One is going to be densification of the network. Okay, we're going to improve the radios as much as we can. We're going to get access to as much spectrum as we can, but there's no alternative in addition to those things but to shrink the average cell radius and have smaller and more dense cell sites. We're going to continue to evolve third generation and fourth generation cellular, add new features to it. Features like LTE broadcast, which allow venue owners and places with a lot of users to supply media and content very efficiently. We're also going to introduce device-to-device communications, which have some very powerful features for public safety scenarios and can result in very high efficiencies for certain types of user exchanges when the users are close together. In terms of the spectrum, there's kind of there's a continuity or a spectrum, so to speak, of options that range everywhere from licensed, as we know it today, the way traditional operators buy spectrum in auction, own it, use it, all the way to unlicensed, such as what Wi-Fi is used in, and everything in between. In the middle of that, we have something we call authorized shared access, which means you have a primary user, which could be a government or a military user, that owns the spectrum. Maybe they have a lot of it, but they don't use it all the time, either spatially or temporally, and it would be nice to have that available. So using a technique that we call authorized shared access, the incumbent can provide it to a secondary user. The secondary user can yield it very quickly back to the incumbent when either temporally or spatially when the incumbent needs that. This is a way to get access to more spectrum, and it's a way to march towards our 1000X. But the real answer, the solution that's going to make the biggest difference is small cells, reducing the average radius of infrastructure and therefore allowing the spectrum to be reused more often spatially. I actually brought one here as an example. So I'm holding up this is actually a small cellular base station, and this is a commercial reference design. It's not a prototype. The chips on here have been available for more than a year. It's a pretty small device. The largest component on here is the Ethernet connector. You notice compared to a phone, it doesn't have a display, it doesn't have a camera, it doesn't have a battery. So it allows us to have a cost structure at or below what a phone costs, and it's actually going to keep going down as we start to combine this with other radios. This one I'm holding is 3G. We're working on a 4G one. We're working on one with 3G, 4G, and Wi-Fi all together. So what do you do with this? Okay, this slide here. If there's one piece of information from this talk to remember, this one is it. This picture is a picture of a neighborhood, and the little red squares on there are homes that have already deployed a femtocell. So this is not a simulation. This is an actual measurement of something that exists today. It's in the San Diego area. And we went out and we drove up and down the roads and logged the signal strength from these femtocells. Now these are femtocells that are closed. In other words, the users have purchased them, put them in their home to improve the cellular coverage. They only work on their own phones, and they use their internet service as the backhaul. But since they exist and they radiate, we can go and measure and ask ourselves what would happen if they were open and allowed other users to connect to them. And as you can see from that chart, if you look at the colors, they range from green to red. The worst is red. But even at the bottom there, minus 110 dB, which is a very weak signal, we can still get over 700 kilobits per second. So if you look at the colors on the roads there, you can see that this ad hoc network created by users buying their own small cellular base stations actually provides a very, very good outdoor coverage. And that's a very compelling piece of information, because a technique like this, with open access, in cooperation with the backhaul provider, with licensed spectrum, can provide very low cost, very resilient, very dense, high performance solution that can actually carry up to 1,000 times the traffic. This chart here shows what happens, let's say over a 10-year time frame, if we use the latest radios available. We, through techniques with the authorized shared access, clearing more spectrum, combinations of licensed and unlicensed, are able to free up 10 times more spectrum. And in this chart, 9%, say 1 out of every 11 homes, puts a small cell, then we get 500 times more capacity out of that spectrum than we have today in today's vintage of technology. If we then turn up the knob a little bit more to one user, one residence in 5 over a 10-year time horizon, which seems achievable because, again, these things are already very low cost. The cost is just going to go down, down, down. So you can embed them into Wi-Fi access points, cable modems, set-top boxes, game consoles, or you can subsidize them or just buy them outright. There's many different models there. If 1 in 5 with 10 times the spectrum, then our results show that you can actually have 1,000 times more data-bearing capability than you do today, without necessarily having to raise the price 1,000 times, because the user's not going to pay more than they are today. They'd like to pay a little less, actually. So we've got to lower the cost, and that's what this is all about, lowering the cost. So just to summarize, we see a demand for densification. We see solutions with small cell radius, combining both licensed and unlicensed technologies, and new deployment models. Thank you.
Thank you, Matt. Randy?
Yes, thank you. And thank you, Rebecca, and to the Commission for the opportunity to speak. So I'm going to talk about XO Communications. I have a couple slides that I'll go through very quickly, and then I'll describe some of the things that we're doing with our network. And I think there's a lot of parallels with what you've heard already. I've got to learn to use the clicker first. Okay, so first of all, we're a CLEC, and we serve only businesses, so this distinguishes us from some of our customers. And I think on the previous panel, we had a representative that spoke to the needs of the enterprise, and he got a lot of good comments there. One thing I would say is that we serve a variety of enterprises, including other service providers. We have a healthy wholesale business. So we're selling large-scale infrastructure as well as serving a variety of enterprises with telecommunications needs. The next slide would just cover all of our things. I won't go through this taxonomy except to say everything here is essentially IP-based. Excuse me. We have a legacy CLEC tail that I'll have some more comments about in a minute. And we have a full portfolio of IP-based services for businesses exclusive of mobility, because we don't operate in that space, although we have a number of mobile operators as wholesale customers. This map just gives you an idea of where we operate. We operate essentially in the largest U.S. cities, the NFL cities plus, I like to call them. We don't have some of the challenges that some of our rural colleagues have. And we've got a variety of physical assets. So we're fundamentally facilities-based, primarily fiber optic networks, but we're also heavily dependent in how we deliver our services today on the legacy copper-based access networks. And I think access networks are the hardest part in telecom by far. So this next snapshot has a lot of words on it, and I'll try to get through it quickly in my time frame here. If you look at what we're doing now, I would say all of our new network investment and product development is exclusively on packet technologies. That should come as no surprise to anyone that's paid attention today. So all telecommunications services can be delivered via IP and are, okay? Ethernet, we would say, is the best way to carry IP on a link-by-link basis, and it's on its way to becoming the dominant access technology. Today, we offer Ethernet access services from 2 megabits per second up to 100 gigabits per second. Roughly 40% of our new IP services sold today are turned up using Ethernet access, either through our own facilities, this is the Ethernet over X comment, or using Ethernet NNIs, which are increasingly prevalent. So we expect that to climb, and it has been climbing year over year. But I have to also point out that the legacy TDM network that was created to serve narrowband voice, DS1s, N by DS1s, DS3s on bundled copper pairs continues to be quite important. You've heard that from a number of the panelists today. I think you heard it from some of the electronics vendors in the form of VDSL and other technologies that are becoming available and are used to continue to mine this very important national resource. The last comment I have here is kind of more towards network engineers, that MPLS provides a great service provider toolkit, allows us to virtualize our networks across public and private IP kind of compartments, or if you like. It's more than just the Internet. IP technologies are a superset of the Internet, although the Internet is probably the best representative there, certainly the best well-known. MPLS also gives us things like fast protection switching and traffic engineering. This next comment is quite important. We have a long legacy tail, even though we're not that old, of TDM switches, TDM infrastructure, that we continue to harvest. And people still continue to buy things like PRIs based on the nature of their customer premise equipment. Okay? New voice interconnect is primarily in the form of VoIP exchange with a variety of providers, although we still have TDM trunking being installed at times. Interestingly enough, we're in the process of removing our Feature Group D network. In terms of capacities, I would say the IP traffic, public IP traffic, doubles every 12 to 15 months. There's some fluctuations there depending on our success in the marketplace and so forth. And this drives successive overbuilds of our national IP MPLS network. Private IP services, so-called MPLS VPNs, are the foundational service for our enterprise customers. On top of that, we like to layer VoIP-based voice services and a variety of other things. Okay? The second to last bullet speaks to the physical layers that are in use by our network. And copper, as I've already mentioned, continues to be important. With a few except for some corner cases, we don't operate those copper networks. We lease them from other providers. But the vast majority of the existing customer base is built over those things. Using things like Ethernet over copper as well as VDSL, there's still plenty of bandwidth to be gleaned out of these things. We want to make sure that they continue to be available for us and others. The statistic I quote here by the Vertical Systems Group said that, and this is March 2013, only 36% of commercial properties are passed by anybody's fiber network. Now, I'm sure if you looked at the GDP percentage that was passed by somebody's fiber network, you'd get a higher number. But the point would be, if you're not inside that fiber service area, then you're relying on something else. And the only thing else is copper, or in an increasingly sort of way, radio networks, mobile networks, as well as fixed wireless. Okay? In terms of new services and platform developments for us in this snapshot of 2013, 100 gigabit per second is here in both the long haul and metro fiber optic networks. We're not the only ones, obviously, that are doing those things. Same thing on the IP networks. That equipment is commercially available and being deployed, and the very largest service providers and enterprises are interested in such things. Cloud-based services are increasingly important to IT departments across the nation and to telecom service providers like XO. So I should go to I've got 2 minutes here to get through another couple of years. So I'll try to be brief. In 2016, now 3 years hence, how do things look? Okay. Well, I think they look pretty much the way they are now, with more. More what? More IP MPLS backbone growth. Multiple IP networks on a common MPLS and DWDM core are very, very common. They're common today. Okay. But what I'm saying here is that many people operate standalone networks for a variety of reasons. We are seeing those things collapse, if I follow the industry properly. Our SONET infrastructure, we think, will be at an apogee in terms of spend. It will still be there. We'll still lease DS3s and things like that. Our decommissioning of our circuit switch platforms will continue, but there'll still be some of those DMS 500s in our case. Not quite as many as Frontier, and certainly not in the Verizon network. There are many, many of these switches still out there. Okay. The PHY layers haven't changed, okay, but I think the percentage of fiber penetration has certainly gone up. What it will be remains to be seen. It's hard to tell because no one publishes their plans. We expect the microwave backhaul. We own a lot of LMDS spectrum. Will start to take off as this cell proliferation that my colleague to my right just mentioned starts to take off. I don't think the fibering out of all these sites will have happened. I'll skip now to the next page because I'm running out of time. Now we're 5 years out. Things are getting a little blurrier, at least in the XO crystal ball. We think we're still got a couple circuit switches left, increased fiber penetration, but copper continues to be important, and I can't stress that, because primarily we haven't seen any timelines from the copper operators in terms of when you're going to have essentially equivalence in terms of passing of the customer premises that are important to companies like XO Communications. So it has to still be there. Plus, it's incredibly laborious to continue to deploy these things. We use today 3G networks, mobile networks, for IP backhaul, for IP services. As a backup, we're going to start using 4G networks as a primary access method. We think in certain bandwidth regimes for certain customers, this is a very viable access technology. Okay, but again, we still have to eventually get on a wireline network, and fiber is not as pervasive as anybody would like it to be. I have one last slide, a couple comments. We're 7 years now in the future. Okay. IP is certainly, the IP networks, I think, at some stage have kind of leveled off in terms of their growth rate. I can't imagine what's going to continue to grow, doubling periods every couple of a year or so. I don't see that far out. Copper, I think, will still be around. It has to be around until we see the plans, the detailed plans, and perhaps the regulatory regime that might be developed around access networks to take its place. Okay. New services, all we know is that there'll be a set of interconnected and sophisticated packet networks running IP version 4, still in version 6. Improvements on reliability and cost basis are never ending in companies like mine. Thank you.
Thank you very much. John?
Thank you. Thank you, Rebecca, and the panel, certainly for inviting us here today. I'm with Cox's technology team, and I wanted to speak for just a few minutes about how we deliver on Cox's vision of connecting our consumers with the things that are most important to them. I'll start off with talking just for a moment about how we approach our planning, and really just two thoughts here that are kind of top of mind for today. The first is just the evolution of technologies and how we deal with that. Certainly we're living in a time where there's very rapid innovation in our space, and I think we see over and over that innovation comes from multiple places. Sometimes it's using capabilities that you already have to solve new business problems, and sometimes it's deploying new technologies. I think it's the mindful balance of those two that enables us to compete effectively in the marketplace. The second part here that I'll just highlight very briefly is just the focus that we're putting now on consumer behavior. Historically, we might have tried to understand the needs of our consumers and be more predictive of those technologies and trends that we would expect them to be looking for. But more and more, with the pace of evolution now measured in months, not in years, we look more to the consumer as a directional guidepost for the services and the offerings and how they're going to utilize them. And this has become a very key important part of our planning process and how we plan our investments. Moving along, I wanted to share just a little bit about our voice platform. I think this is something that's interesting for Cox. Cox was one of the first cable providers to enter the telephone marketplace. 1997, we entered the marketplace using what I would call certainly typical technologies at that time, TDM-based, circuit switching, TDM interconnect. We built out a robust platform and offered services to many, many of our marketplaces on that platform. Later on in 2004, we transitioned over to packet cable-based technologies and utilized a converged access architecture built on top of our DOCSIS IP infrastructure. This brought along the opportunity to combine both voice and data services together on a single access technology, simplifying our architecture, and this drove the bulk of our expansion since then. Beyond that, we've also built out a robust set of enterprise and business offerings that are based on both these technologies as well as cable packet multimedia or SIP-based services. These services, broader in their offering, include other access technologies, our hybrid fiber coax technologies, as well as passive optical networks, as well as point-to-point fiber technology. So really a broad basis of different access technologies. As we talk about the transitions that are going on in our voice services platform right now, there's really a couple of key ones as we look to converge on our IP-based technologies. The first is we will continue the transition of our customers from our original TDM infrastructure over to the packet cable-based infrastructures and the convergence that brings in our access network. That's a key opportunity for us. The second is the continued migration towards IP interconnect. Cox has been moving down this road for some time. Approximately 50% of our long-distance traffic is now handled via IP interconnect. We certainly have a large amount of local TDM interconnect still in place, but we would continue to look to make that transition over time. As we think about these continued evolutions in the voice marketplace, we will continue to look for opportunities to converge towards IP-based technologies. Next, I wanted to talk just briefly about our video services platform. In many ways, our video services platform shares a very similar legacy to our voice services platform. It was built on a number of technologies a while back, and frankly, these technologies, while some were proprietary in nature, enabled it to grow and to scale very rapidly, and even today provide a very robust set of services that our consumers continue to find and enjoy a lot of benefit in. That being said, much like our voice platforms, there are opportunities through convergence on IP-based technologies to extend the reach of this platform. IP is certainly reshaping the marketplace in video. Certainly the ubiquitous reach of IP access networks is changing the way consumers are consuming our products and services. Our top priorities are to expand content and bring very compelling experiences to our consumers. That being said, IP technologies are certainly a core of how we are doing that going forward. At each layer of our network, starting 5+ years ago, at each layer of our network, we began to evolve our core technologies underneath, enabling, where possible, based on IP open technologies. The benefits of this our consumers are now enjoying today, as they are able to enjoy our live video services across a broad number of devices, including tablets, phones, computers, laptops, as well as the traditional TV set. As we think about how we're achieving this, the keys here are focusing on open IP standards where applicable. This has enabled a great opportunity for reusability across our technology stacks, speed to market. We have been big proponents of supporting open standards where applicable, such as HTML5 and DLNA, and we'll continue to do so to further this cause. As we think about the evolving video marketplace, I'm sure that it will continue to evolve dramatically over time. However, I feel pretty confident with the choices that we've made are enabling us to be prepared to compete in the future. Lastly, I wanted to talk for just a brief second about our evolution in our networking technologies. I'm not going to really dive off into many of the technologies. Certainly the group here has done a great job of setting that stage. But really we'll just talk about one trend that's really impacting the consumer, and that's the ongoing innovation that's going on here. Consumers are benefiting tremendously from the technology innovations, many of which this group has touched on already, whether that is our DOCSIS technologies, 4G in the marketplace, Wi-Fi services. These are all great examples of the innovations that are going on in the marketplace. Parts of the Cox network operate at 100 gigabit per second. But these are transitions that the consumer is largely unaware of. And that's really the point that I would like to spend for just a moment and talk about, and that is it's the role of the service providers to bring these technologies to the consumers in a manner that is seamless, brings compelling services, and transparent to the user. Reflecting on all the conversation and the transitions that we're talking about consumers are going to undergo, it would be very easy to lose the focus on what it means to the consumer. So stewarding them through these many changes across our voice platforms, our video platforms, our network infrastructure, bringing new technologies like DOCSIS 3.1 that Ralph shared with us this morning to our consumers in greater and greater speeds, or Matt's new small cell solution, are all great opportunities for the consumers, but ones that we must help them through in a seamless manner. As we proceed, we are very focused on fulfilling the needs of the consumer, focusing on simplicity, consistency, and reliable solutions. These plans, as we focus them, will deliver on bringing the best customer experience, enabling the most advanced technologies, and connecting people with the things that they care about the most. Thank you.
Thanks, John. We'll have an interactive discussion with all of the colleagues at the table, but I think I'll start off by asking, XO presented sort of a snapshot of where their network's going to look in 3 and 5 years, and if the other panelists could do so. And in particular for Verizon and Frontier, XO talked about both copper and TDM being present in their network for the next foreseeable future, next 3 to 5 years. So how do you see that transition, and what's the key driver of the technology transitions?
One of the things that we're focusing in on is looking at copper infrastructure where it's not working up to the standards that we want it to work at. We're not necessarily going out and ripping copper out of the network right now, but one thing is kind of struck me. And I wrote down, he said right about now we're at about 36% of enterprises past have fiber, and in 4 years out that grows by probably about 100% or so. Up to about 65%. The one thing that struck me is if we have to maintain copper where nobody's using it, which some folks have talked about, I really don't see even potentially hitting that 65% because all of our money is going to be tied up in maintaining a network that is somewhat limited in technology. So I think one of the things that we need to look at is in areas where it does not make sense for us to maintain copper, is to accelerate the movement off of that copper onto other technologies that are available. To go out and support a network that is both environmentally sensitive and somewhat limited in scalability doesn't really make a lot of sense. So I think collectively as an industry, it's probably in our best interest to figure out how we could leverage additional technologies today and see what we could do to try to accelerate the shift over to newer technologies. But to do so while involving the customer and making sure that they're comfortable with that transition. I'm just not suggesting that we go in there and just roll over everybody, but I think we need to kind of look at the best way to approach the future.
And just to follow up, what about the TDM? Sort of what's the pace of you switching out your TDM switches and different architecture?
Well, TDM, I think a lot of people are moving themselves off of TDM. I'll just talk about it from a consumer perspective. I know a lot of the people that are out there adopting our triple play packages, for example, are taking advantage of the fact that they can move over to a VoIP product. So at some point in time, we are reaching a juncture where the TDM switches are really becoming obsolete. I know we talked about a lot of manufactured discontinued equipment. I've been focused a lot on what's been manufactured discontinued or tough to support from an outside perspective, but the same holds true for some of our network elements as well. And so, I think looking out a couple of years, I think the TDM switch is kind of going to fade off into the distance.
So I'll start with on the TDM. Certainly, it's going to be in parts of the network for, I think, in the next 5 to 8 years easily, and maybe in some places beyond that. But there's going to be certain triggers that cause us to move forward. I don't know what all those triggers are, but there could be simple things like, a storm like Sandy that says, I'm going to go back and replace. Why would I go back and replace stuff with 20-year-old technology? Why don't I take this opportunity to move forward? It could be in a particular area, a simple thing like a road move. So if I'm going to have to be forced to put in a new network, maybe I put that new network in as fiber to eliminate some of my copper problems in the area. It could be things like power consumption. These large old TDM switches are power hogs. I mean, they suck down the power like crazy. And, so that may be the driver. But I think more than likely it's going to be all those things that are drivers that add to the tipping point that causes us to move forward in a particular area. So there will be some areas of our network and some markets that will tip before other areas or other markets tip, just because we're fortunate in some areas and we're not fortunate and Sandy comes along in another area.
Anyone else want to speak about sort of a snapshot in 5 years?
I'll say a couple more things in the XO context. So my colleague from Frontier mentioned some of the drivers. For us, some of the drivers are things as mundane as real estate leases and things like this, which will drive us to essentially decom a circuit switch. But then there's a desire to maintain the revenue that's flowing through the switch. And in some cases, that's still pretty substantial. And nothing is more uninviting, if I can put it that way, to migrate existing revenue base off of a TDM switch onto a soft switch or another TDM switch, the next popover sort of thing. So there's lots of factors. I agree with that, and there's this fine economic balance that has to be struck. I just continue to remark that there are thousands of these devices in operation in the United States today, and it's not going to get any better. Certainly no one, I don't think, is spending any money on them in the sense of augmenting them or anything else. Maybe it's a business opportunity at some stage for people to remanufacture cards and to take them over and to operate them on the behalf of the current operators. I don't know. It's a tough thing.
I want to go back to something Tom was talking about in his presentation. The last panel we had, there was some discussion about cutting the cord. 34, I think the most recent figure is 36% of the population has cut the cord. But that's a consumer choice to go mobile only rather than having a fixed line at the home. The kind of cutting the cord that Tom was talking about is a different. It's a network cord cutting and based, as I understand it, on where Verizon has already planned to have Fios or where they plan not to have Fios in the future. So if you could speak a little bit more to the decision that goes on as to where and sort of what pace you might be deploying fixed wireless solutions is the one you were showing us earlier. And then I guess related to that, and then maybe at this point Matt can jump in as well. You were talking about putting this on your 1X network, so it's a voice solution. But for those customers in those areas who want data service as well, what are you looking at there? Is it, again, eventually the kind of thing that Matt was talking about, leveraging your existing mobile network, putting small cells in? Just,
Okay.
I can answer the question for you.
That's okay. As we look to where we're going to deploy the VoiceLink product, we're focused on areas where we're spending a lot of money in maintaining the copper plant. In addition to spending the money on the plant, we also have customers that are not very happy with us. So we're essentially giving them a reason to leave us. And as you point out, it is a voice-only device at this point in time. So we're looking specifically at offices or at customer locations where they're just completely aggravated, and we're spending a fortune to make them aggravated, which doesn't make a lot of sense from a business perspective. And we can easily identify those areas or clusters of customers where they have a bad service experience. The reason we decided to go this route as opposed to just telling them, hey, we're not going to do this anymore, let's throw COLA obligations on the side for the time being, is we wanted to maintain the relationship with that customer. I think Henning pointed out earlier, there's a big discussion or question out there of who does what. And we're looking to maintain that same relationship so the customer will always come to the people that they've gotten used to coming to in order to check billing issues or to report a service issue or to have a general question about what's happening. So we wanted to deploy this in their network, in their homes rather, and make it almost a transparent device where it essentially just does the same thing that copper does. And again, we're focused on areas where we don't presently have fiber today, and areas that do have a bit of copper problem. As far as looking forward to the future, we are having discussions about how we could incorporate data into this as well. There are some areas that we've gone to, interestingly enough, where we've deployed this device, where it is a very rural device. It works very well from a voice perspective, but the folks are out there are still using dial-up to a certain degree, and so we're looking to see what we could do to leverage some of the technology that we have available in the wireless world, but maintain that same relationship I spoke to a minute ago, and create that same sense of comfort with the customer so they're kind of getting the best of both worlds. Those discussions are just kicking off, and hopefully we'll be able to pull something out within the next couple of months.
So would that mean in your networks at some point in the future, don't have to pick any date, but that you'll either have Fios or you'll have some fixed wireless solution, but you won't have ADSL, VDSL?
Well, I think we're going to have at some point a combination of all three. And it depends on, the demographics of the area, what the customer requirements are. In some cases, we might not have a very good wireless signal, for example, but we'll have a copper infrastructure out there, so we'll maintain the copper. So I think we're going to have all three elements working at some point, at least for the foreseeable future.
I wanted to follow up a little bit on the kind of transitions that are going on that we've talked kind of throughout the panel. Namely, one is at the access network, the last mile, then on the physical infrastructure, then the TDM/IP on the access network side, on the consumer-facing side, and then TDM/IP in the core network side. These all seem to be happening, relatively speaking, at independent timescales and in geographic diversity. So I wonder if we can more closely look at each one of those now. If we look at the backbone, if you were to say, just ignoring access, consumer or business access, in 2016 or so, or maybe 5 years down the road, will we still have kind of class 4 type network switches, kind of a classical route, or will it basically be, even if businesses still themselves have a PLI, everything else on the backbone side will be IP? Or is that still too early? Anybody want to venture that?
So, this will vary by network, obviously, but I'll speak for our company. We've essentially been VoIP on the inside for LD traffic since 2001 because we had a big enough IP and capable enough IP MPLS network with class of service, and we had a large-scale national soft switch deployment. So we've been VoIP on the inside for a long time, and I guess you could call our Sonos soft switch a class 4 if you so desire, but it's not like a DMS 250 or something like this.
Right. Yeah. Okay. The others, anyone to comment on that?
So I think that what you'll see is a transition where maybe we use the frames or some of that to serve those customers that don't want to move, but the guts and the brains are going to move all to IP. So there's several vendors out there that are working on that very strongly now, and I think that's probably what you'll see happen is because these networks are like oil tankers, you don't turn them quickly, and so it's a step-by-step process.
And the other component that I was wondering about is indeed when you're talking about on the Verizon side and the wireless side. Do you see we're talking roughly about 25 gigabytes today for median home usage for broadband users in that. That seems challenging to do in a 4G type of environment, given the average consumption there. So do you see that primarily as, you mentioned hybrid networks, that light users would migrate to 4G and others, if they can not get fiber, obviously, would be using DSL, or how would you envision that?
We haven't divided it into different tiers depending on the usage of the end user. Right now, again, we're just getting into the discussion about the capabilities. I think a lot of it, as we pointed out on one of the earlier panels, a lot of it's going to come down to the cost to the subscriber. Some subscribers might be willing to pay for like LTE costs. We have a base of customers out there who are paying for all-you-can-eat DSL very competitive rates, and by that I mean dirt cheap. And so it's just from a business perspective, it's going to be tough to get those people to get off of one and onto a more expensive network. So this is something I think we're going to have to look at very carefully.
Well, I'd like to comment on that as well. If you have a 4G network on a cellular band or PCS band of today with a large coverage radius, and it covers a couple kilometers, and there's a bunch of users there, and you're asked, can you supply 25 gigabytes? Then yeah, it's challenging. But the reason it's challenging is more because of the radius rather than the modem. And if you are able to reuse that spectrum much more often, then it's not challenging at all. You can definitely achieve it. In fact, that's exactly what's happening with Wi-Fi today, which I just read a Cisco report recently about the total amount of the entire internet traffic that's carried that way, and it's getting to be a pretty substantial fraction. So if you normalize to radius, then you can actually outperform with 4G versus some alternatives, and if you normalize the amount of spectrum and the amount of radius. So that's the model that we want to get to. It's certainly true what you said today. If you have a tower and it's covering a large swath, which used to be the goal of cellular, and every one of those users has got devices like these and they're trying to pull 25 gig a month, then you're going to have trouble. But that's why we got to densify, and that's why we got to shrink the radius.
But then you have kind of a chicken and egg problem, where you kind of that works if you have fiber deep in the network, because you're not going to run one of these 100 megabit 4G out of ADSL. Doesn't seem like a good model.
There's no doubt that I'm not sure I call it chicken and egg. I would just say the demand for backhaul is just going to be there. We've got to have it. You're going to need that for any of these class of solutions. Absolutely correct.
So what radius would you anticipate? What would be, if you were to design this densification model, particularly in the areas that are unlikely to have fiber, so they're not the densest or wealthiest areas, but they are the ones where you could deploy backhaul fiber to some, I guess, aggregated number of households. How many would you serve out of each one of those small cells, roughly speaking, in order to make that model work? And not run fiber to every household, in which case you haven't really saved any money to begin with.
Well, I need to be able to put specific numbers. You have to give us some figures and so forth. But it's definitely the case that for a given backhaul, if you've got a certain amount and you want to serve users with that, and you compare whether it's 4G or Wi-Fi or 3G, they're really all going to be limited by that same backhaul. That is going to be the determining factor for all three of those, last segment solutions.
I wanted to talk a little bit about one of the things we're looking at is sort of the resiliency and reliability of the networks as we transition, and one of them from copper to fiber. So Tom and Michael and Exo, if you could speak a little bit about, as you've moved from copper to fiber, how has been the difference in sort of the reliability of the lines, like the troubles that you're getting per line from fiber versus copper, and if you've been able to sort of quantify the cost savings of doing so from the OpEx side?
Well, as I said, last year we moved it was actually about 223,000 customers off copper and onto fiber. We think we haven't saved an equivalent number of dispatches because, some of that had to do with provisioning work. We were going in and put the customer right onto fiber in the first place. But we've saved well over 100,000 dispatches. And these things really kind of add up, depending on whatever the labor cost happens to be in a particular area. I had my folks do a little bit of a study prior to Sandy, and we looked at the copper infrastructure. We looked at people who had chronic issues with copper, and we looked at people that we had migrated over to fiber. And in the month of September, we had nearly 3 dispatches per 100 lines in service on the copper side. When we looked at people who had chronic history, it was over 5.5 dispatches per 100. And when I looked at the folks that we migrated over to fiber, it was 0.61 dispatches per 100. And again, that's outside plant troubles to outside plant troubles. And so, we've gone back and we've done not only from a dispatch savings perspective, but also from a customer satisfaction perspective. And I think it's more than offset the cost of migrating these people over to the fiber network. It's been pretty significant.
So I would say the stats of the troubles are similar to what we see. Our challenge is getting the fiber out into these very rural areas and the distances that we have to build that fiber. So the cost of doing that, it's not a very quick payback at this point. That's really the biggest challenge. And then the other second biggest challenge is people want to continue to dig our fiber up. So if you could solve that one for us, it'd take a lot of troubles out of the network.
Now, can I add one little thing? It's an interesting point in terms of the cost to build out. The beauty of what it is that we're doing is that this is part of the fiber rollout that we started. I think somebody said this morning it was 10 years ago. It was nearly 10 years ago. So it's not. This infrastructure is already out there, and it was really just a matter of deciding to take that infrastructure that's literally in place next to the copper and use that to provide other services. So that helped us, pretty significantly.
And we're certainly leveraging where we're providing the backhaul to the towers for our customers that sit on both sides of me here. I mean, we're certainly leveraging that, to try to overcome that copper network. So it's all about trying to leverage what you have and maximize it.
So I would agree with everything my colleagues have said. We're certainly very familiar with the difficulties in getting copper loops kind of turned up, and when we put our own electronics on them. Once they're up, they tend to be quite reliable, except when they get submerged and things like that, as has already been pointed out. The problem, and I just have to go here for just a little bit, and I apologize in advance perhaps, but the problem, everybody wants to get to a fiber network if they're just a pure engineer. That's for sure. A fiber network serving very dense cellular systems for the mobile subscribers, but also serving pretty much everywhere for all of these gobs of bandwidth that we want to have everywhere in the workplace, at home, and to serve our mobile devices. The problem we see, though, is, and we've said this to our current copper loop providers, T1 providers. We'd like to get to a stage where we can just buy on an equivalent or better basis Ethernet virtual circuits across a Ethernet-based, fiber-based access network with the same cost basis that we can achieve through unbundled copper elements with our own electronics on them, which are available to us, of course, because of the good work of the Commission and others. Okay? But you don't see any of that in the new next-generation networks. That, in a nutshell, is our difficulty. Okay, so I think we would all agree that the end point, from a technical perspective, is going to be a combination of fiber and radio, with vestigial use of copper. But what happens to alternative access? What happens to competitive providers? It's unclear.
So, if I understand the discussion so far, all the investment going forward is in IP-based networks, but TDM-based switches are going to exist for quite a while, and so you'll have some aspects of that for 8 or 10 years, I think Michael said. Tom is somewhere in the order of 8 or 10 years, you'll be supporting some form of a TDM network, roughly. So, and I understand that there are costs of that duplication. What would be helpful to understand is how you quantify or subdivide those costs. Is it, you talked about back office. Can we put a little more meat on the bone as to what the key cost drivers are in having to support two networks? And John, if you have, because it could be the maintenance of the physical facilities, it could be as the training. In terms of informing policy going forward, it would seem to be helpful to know, for this fairly long period where we're going to be supporting two networks, what the key cost drivers are. So, and if they're,
I might start real quick. And
sure.
So for us, I think it comes into a couple buckets, and I don't know that I can give you a specific percentage breakdown, but I thought Michael did a great job of telling the story of the legacy of maintaining those plants. Certainly that personnel and that skill set is an evaporating quantity in the space, and so maintaining that is certainly one of the challenges. For us, I think some of the other challenges really come down into two other big buckets. Just platform obsolescence. The whole conversation around getting the hardware is increasingly becoming challenging. We do have sources today, but over time that continues to be challenged. And then the third one is the physical reality. They do take up a significant amount of our physical space, and I think we'd like to repurpose that for better technologies. And so over time, in some cases, that is driving the transition for us, where we face a facility expansion project, and the alternative is to remove the TDM infrastructure instead and create the space. We've gone that route. So I would say those are three pretty good examples of where it's impacting.
So I think there's probably more data points out there, but one data point I just looked at. So I just took our cost per customer for our TDM switches that we pay for maintenance over the last 3 years, and that cost per customer has gone up $1 million, because as we've lost customers off of that network, then the cost per customer goes up. So, That's just one data point, and I think if you sit down, you could analyze a number of data points in the network. But
yeah, I think as we go forward, not necessarily today, it'll be helpful to understand, because this is going to be a reality it sounds like we're going to be living with for quite a while, that there are a variety of costs, because there are going to be two networks for a decent amount of time. It may be very helpful to understand what imposes costs of that reality that is going to exist. Tom?
Yeah, I mean, the only thing I would add is, I just kind of grouped them together in some big buckets. Power costs are one we discussed. Personnel, the whole training issue, maintaining, in some cases, duplicate field forces or even switch forces to maintain this stuff. The availability of parts, real estate, taxes, a lot of this stuff adds up. Pole attachment fees, a lot of little things add up.
I think it'll be helpful to get as much detail as we can go forward on that, because if there's a way to spend money otherwise that would allow innovation, I think that would not harm other policies, then we should look at that.
Very good.
A question for John. So on this morning, Ralph from Cable Labs identified that DOCSIS 3.1 is going to have more opportunities for business. In the last panel, we heard that cable really isn't, or didn't appear to be, a big player in the business market. Can you speak to how one of your slides talked about sort of a focus on the business market, how the technology transitions have enabled this, or what's your focus on what type of services are you providing to the business community?
Sure. So Ralph touched on this morning a number of the capabilities that have come over time in the DOCSIS roadmap, and with each release there have been more and more capabilities, and many of those have been aimed at driving the feature set into more of what an enterprise space customer would want. That being said, I think 3.1 primarily provides more speed capability more than other feature sets. So as I think about how it will step into the enterprise space and be a solution, I think it will help us to address probably some of the concerns around peak speed offerings as well as symmetrical services, are a couple of areas where 3.1 would be a good solution in the commercial space. Certainly, while we look forward to 3.1 and what it can do for us, those needs today, we also offer other access technology solutions where appropriate. Our HFC network is the most prevalent, and it passes the most businesses today, but we also have fiber networks that are in front of many of those businesses as well. And so we offer, whether PON-based architectures as well as point-to-point fiber services to solve some of those other business needs. So I think for us, it's a suite of products that help address those issues.
All right, just to follow up on that one, in another conversation, I was actually somewhat surprised. I don't think it was your company, but another company in California was offering wholesale access on their network to address as an additional bit pipe, so to say, into businesses in particular. Is DOCSIS 3.1 enabling that type of separation as well, so that you could at least theoretically offer a independent IP connectivity where the IP part, where you're essentially offering Ethernet or packets of some sort, and the third party offers the end-to-end solution, or you don't really see that as either attractive or possible?
So I think there's lots of things that are possible. I think it comes down to what is the most economical solution to meet the needs of the consumer. And so in some cases, DOCSIS may be a great solution for consumers in that space. A lot of times it comes down to their requirements. Typically, depending upon, again, the symmetry of the service and the peak speed rates that they're looking for, will determine what solutions we'll be offering the customer.
And I wanted to also follow up. You made an interesting statistic on the number of businesses passed by fiber over time. But you hinted at that is not, should I say, weighted by business size or revenue. So it's account. And so I'm curious if you had any insight in the sense that will it be that essentially it's a combination that in your most long-term projection, 100% of, let's say, large business tower type of commercial real estate in big cities will be fiber, which is probably pretty close to what we have today already, but maybe only 10% of small, more rural business, your gas station, your medical complex somewhere in the strip mall, those type of your hospitality organizations on a county road, those would be passed by fiber. So I think there seem to be a very diverse number of situations all lumped into that one statistic.
I agree, Henning. That one number kind of suppresses a lot of information. So my sense today is that for very large enterprises in major metropolitan areas, the central business district, there are multiple fiber alternatives. Certainly that's the case in Manhattan. But even Manhattan, and Sandy showed this, there were lots of buildings that were served by copper and copper only that were impaired. And I won't speak for Verizon, but we have some understanding of this because we were lessees of the copper plant down there. Not all buildings were served by fiber in Lower Manhattan, which I guess surprised myself, if no one else. Okay, so I think it will be the case, and I understand this completely. If I were building fiber networks, and we are to some degree, you go where the money is. There's just no question about that. Okay, so there will always be underserved areas. We heard that earlier on the panel in terms of more rural areas and demographics and so forth and so on. So that one number, 36%, which will grow, suppresses a lot of information. It avails you nothing if you're not inside the circle. Okay? But you might still contribute significantly to the gross domestic product of this nation.
So is there any way to get better estimates on kind of a distribution on that?
So I hope so, because we rely on third parties like the Vertical Systems Group and others to collect those. I think it would be wonderful if the Commission itself could extract that sort of information from the network operators.
Yeah, I have a couple of separate but related questions, both for Michael, I think. Based on some presentations earlier today, there was the suggestion that by 2020, any of the DSL technologies, even VDSL, wouldn't be sufficient to meet consumer demand. I know there's it's based on projection of consumer demand, but that only fiber would meet those needs by then. So I wanted to talk to a little bit about whether you think 2020 and your plans, are they consistent with that kind of projection? And then, again, a very different question, but also in that same presentation, it was suggested that the sort of right technologies to deploy depended on population density, and that and a below 10-person per square mile population density, it was more economic to deploy wireless or even satellite technology. You'd mentioned that, if I recall correctly, you said that your average population density is 26 people per square mile. So, based on a simple sense of averages, that means you got a lot of areas that are fewer than 10. And yet, unlike Verizon, unlike AT&T, you don't have a large mobile network to leverage and maybe move. But Tom mentioned, and I know AT&T has written about taking some of the areas in which they believe it's too expensive to maintain copper and too expensive to deploy fiber. That wireless seems like a better solution. So, for you and for some of the other local exchange carriers that don't have a wireless alternative, do you see it somewhat differently? Is it sort of not, or do the economics not quite work as well for you?
The economics are challenging. There's no doubt about that. And I think, we saw several years ago when Verizon went down the path of building, fiber to the home, that a lot of the vendors kind of stopped with the copper technology. But then if you look over the last couple years, I think everybody realized that you're never going to build fiber to every home in America. So then all of a sudden there was a lot of money put into research. And over the last couple years, if you look at the leaps and bounds that have taken place and how much you can do over copper, it's changed quite dramatically. So I don't know about 2020 if that's going to be the tipping point where we have to have fiber to the home. I think there's going to be many other areas that we talked about before, whether it's building fiber to the cell sites, it's building fiber to the small cells that are out there that are going to get fiber closer to a lot of homes. And so that distance is going to become shorter and shorter, and then maybe there is, a technology that we develop with fiber on how to deploy fiber that all of a sudden is the breakthrough. So it makes deploying fiber, if you could cut the cost of deploying fiber in half or a fourth, in many cases, man, that really tips the business case around. So I think, I really think that somebody could make a pretty penny if they could figure out and concentrate, on how you deploy fiber much more economically than we have in the past. So I think there will still be copper in the network at 2020. I think there'll be far less by that time. So it's going to be, I think a fairly slow migration just because of the cost factors, unless we come across a technology that says, okay, I can put, something up and I can shoot fiber 5 miles down the road and connect it to something else and drop it and off you go. So I think that's, if you don't, then I don't think you're going to get customers that can afford to pay for it if you don't do something else. Now, the way we've approached this is we did a partnership with Hughes from Satellite. So, there's right now we have about 12% of our homes that we can't pass with a DSL solution. So we rely on Hughes to cover those very, very rural homes, and that's that combination in partnerships. And I think there's going to be more and more of those partnerships. I mean, if you look at the wireless backhaul, there's partnerships with both of these guys on my left and right now. If they had to go rebuild fiber out to every one of these, they would have been a lot less 4G rolled out today than there is. So I think there's a couple areas there, and that's kind of what we see. We're going to take every opportunity we can to try to get fiber deeper in the network, and if we get some other reason to do and build that, then we'll certainly try to leverage that to get it to the home. But that from that curve or from that road that's running outside the farmhouse, down the lane 4 miles to the house on a farm, that's a costly proposition unless somebody wants to pick that cost up.
Just to follow up on the fiber cost, we were trying to get a little bit more detail on that during the first panel, but that was probably not quite the right group because they didn't have the task of actually digging. We just ship boxes. UPS does the hard work, so to say, we delivery for them. You don't have that luxury. So I'm curious if you have a notion of, just as a rough order of magnitude, if you're looking at fiber build-outs, particularly in more rural areas, and this would presumably apply both to Verizon, like having Fios covered in more urban and suburban areas at this point, as well as certainly Frontier, do you have a notion, if you could wish for a breakthrough, is your notion that the cost of 30/70, which is what I've heard, hardware versus digging, when 70% is digging or civil engineering or stringing, presumably, and 30% is the fiber and the electronics, what is the main cost driver that if that would change, you would suddenly say, hey, this is starting to look attractive again?
Well, I think your figures are pretty close, and that fiber is not that. I mean, because if I go into a new area, if I have a new housing development, I'm going to put fiber there. It's cheaper than trying to put copper there. There's no doubt about it. So, I want to in new areas, it's definitely the route to go with fiber. There's a lot of factors that we run into. So, whether I want to, if I have to put it in the ground, then it's at least 3x more than if I have to put it up. But if I put it up, then I'm susceptible to, more storm damage. So there's trade-offs in everywhere you go. If you look at, also terrain's a huge factor. If I'm building it in West Virginia versus Iowa, the cost is dramatically different in those areas. So there's a tremendous amount of factors. I mean, we can certainly come back with some average costs for you, but a lot of factors to consider. Right-of-ways, I mean, I can't tell you how many times we've been stopped by trying to get across a railroad, to bore underneath a railroad or something like that. And I think everybody probably here has got that same experience, held up months on a project trying to just sort out the paperwork to go through. So there's there's just a lot of factors.
The only thing I wanted to toss in there is that I think you hit the nail on the head. We are trying to figure out new ways to do things. We just started microtrenching in New York City because as difficult as it is to try to get something out to a farm, it's no piece of cake working in New York City. So we're looking, we literally travel to other areas where they've had some success, whether it's over in Europe or talking to people in the Pacific Rim to see how they've done things. To see if there's anything that we could leverage to potentially make things a little bit easier. We were talking a little bit earlier just before the panel about the different ways to get fiber even closer into the apartment or closer into the home so we can move equipment further up to reduce the cost or even the footprint of the equipment that is necessary today to provide fiber. So I think it's going to be a constant battle to always kind of chip away at the cost and figure a better way to get it out there.
We have one question from the audience, which I think might build on something, Randy, you mentioned in your opening remarks, but I'm not 100% sure. It says, for the operators, can you elaborate how you will mix fixed access and wireless networks and generate additional revenue?
Sure, I'll take a shot at that. So for us, we tend to, first of all, back to the notion that IP is the fundamental bearer plane or transport for all services, right? So I've got to get an IP path to the customer premise, and then it comes back to, well, what are the requirements? What is it the customer's trying to do? How many people are they trying to support in their business, in our case, okay? So this kind of quickly drives you towards what are the access methods that one might use. So it's kind of like a decision tree that we use today, along with the availability of the various alternatives, copper, radio, or fiber. In certain regimes, clearly you're only going to use fiber. If somebody wants a gigabit Ethernet connection to do something, then you're on fiber, or maybe fixed microwave, okay? If they want a 10G, you're definitely on fiber, okay? But if they only need 3 megabits, 10 megabits per second, you've got pretty much all three of the physical layers are open to you. And we go by least cost. Surprise, surprise.
All right, just quick for Matt. Your thousandfold over 10 years challenge. Is it something that sounds a little Moore's Law-ish, a little more aggressive even? Is it something that you figure you can report on, keep people apprised as time goes by? Like how do you think you'll measure it? Other than
how do you measure it?
Yeah.
I think we can report on it and those sorts of things. It helps to define what we actually mean by that. And if you think of, like, let's say a metropolitan area, like say this area, in Washington area, and you draw a line around the whole area, and you ask how many bytes are delivered to cellular data services. That's the number that we think will go up 1,000-fold. That doesn't mean that a particular modem is going to get 1,000 times faster. It's the product of the number of users that are using these kinds of devices times which fraction of them are data-consuming devices and how much they're consuming and how many there are and how many hours a day and all that. That's what's going up dramatically. And it's going up very dramatically actually around the world. There are enormous cities in Asia that are just getting started with 3G. They're going to go to 4G, and that amount is going to go up. If you drill down to any particular area, it's not just going up in one particular residence. There's more residences. There's more construction. There's more density of population. So some of those factors are accounting for several-fold increase just with a given vintage of technology. It's just more of it's being built out. So anyway, I think we can actually measure it. We can go out, and we have, and it comes down to the cost. If you put in X investment and you get Y throughput out, we want it to be in the future. You put in X and you get hundreds of times more performance at the same cost, because we kind of feel that the users aren't going to tolerate a monthly plan any higher than what it currently is.
So with that, I want to thank our panelists. This was a very interesting discussion, and thank all of my fellow colleagues here, and I think that concludes our workshop, so thank you for everyone.